already done the introduction to me, and what we know as an industry in the plumbing field, that high-rise buildings have an increased risk issues with SWR, or drainage waste and vent, as we call it in Europe and in the US. And what happens with in the particular building services and plumbing is that the codes and standards that we follow are incorrect for high-rise buildings. This leads to empty traps. We have more complex pipe routing. I'm sure there's many architects there as well. They like to have offsets, changes in location. Obviously, with vertical buildings, space is key, and we don't want to maximize the space for building services. Obviously, project cost, on-time project completion, every delay costs everybody money. Acoustics, does the plumbing cause an issue with noise within the apartments? We don't want to hear our people living above us when they're using the bathroom, for example. And again, performance criteria and maintenance once the building's also completed. So these are some of the basic challenges we have with high-rise buildings. Can you see my screen? Yeah, there we go, yeah. So we do this as a manufacturer for our partners in India, our company called Ashavad, and they're part of the Aliaxis group. And we work as manufacturers of our own development, but we also work with universities to understand the fluid dynamics for high-rise. And one of our key partners for this is Harrogate University in Edinburgh in Scotland. So again, when we're looking at the fluid mechanics, the research, we do this through working with universities around the world. So plumbing is basically, we need plumbing for all our buildings. If you want to live in a building, you've got to have plumbing, and if we've got to do that, we've got to get rid of our waste. And one of the primary key aspects of a building drainage system is the barrier, because we have the living space, and then we have our drainage space, and that's the water trap seal. So if we don't have that trap seal, going back to early plumbing codes, Victorian plumbing codes, that barrier is there to protect us from what we put into the drainage system and what comes out of it. The current codes are a risk for tall buildings because they're written and drafted for low-rise buildings. So if you look at your National Building Code, the IPA code, the IPC, UPC, the building regulations in the UK, the AS 3500, all the data that's in there for the MEP engineers are based on research done in the 1950s and 60s and applied to the plumbing codes now. And they've only ever been tested to a maximum of 30 meters in height. And all the calculations that we use, so drainage fixture units that you use in India, litres per second, were done in the early 1920s and up through by Wise in the UK in the 1970s. So again, all the data and calculations that we use for drainage are all A, very, very old, and B, all done for low rate and only used to clean water. So we're building taller and taller buildings, mixed-use buildings, and are the plumbing codes fit for purpose for tall buildings? So scientific studies show that pressure management is a key part of protecting the water trap seals. And when we have our code standards, they're done in litres per second, and they're all done in what we call steady state. But a drainage system, an SWR system, is inherently unsteady. So again, we've got a challenge straight away that we have plumbing guidelines for steady state calculations, but drainage is inherently unsteady. And this unsteady makes airflows and pressure transients, and these pressure transients affect the water trap seals. And the taller the building, the longer the response time. So we call that the pipe period, and this leads to failing drainage systems. So we're seeing this more and more with tall buildings around the world. And because it's random, and for example, it was random that if you have a shower and you use shampoo, it will speed the discharge rate. If you use conditioner, it will slow the discharge rate. So just by having a shower and the chemicals you use for washing yourself changes the speed of the discharge within the drainage system. And the more buildings are taller, the more chances that there's going to be events that are going to affect the protection provided by the water trap seals. And in fluid mechanics, we look at all our calculations and standards based on the water, but in fluid mechanical terms, the primary fluid is air. So it's a ratio of 80% air to 20% water solids. And this air, that is the primary fluid, is not accounted for by high-rise buildings. If we look at some examples of some tall buildings and failures. So we go from the left, which is probably the world's tallest building, Burj Khalifa in Dubai, and this was the system test carried out in 2008 when they handed the building over. Then we go moving on to Taipei 101 in Taiwan, and this happened when the building was 70% occupied, and we can have an effect of these tall buildings of when we get the plumbing wrong, what happens to the drainage systems. So obviously you don't want that to occur in any of your buildings. And also, we've got an aspect with the current pandemic that occurred with SARS-CoV-2, and there was a lot of research, and a lot of the research that we did with the university actually happened and started back in early 2000s after SARS-CoV-1, is that if we have a pathogen such as COVID, SARS, norovirus, we tend to get sick, and if we're sick, we tend to use the drainage system to get rid of the sick or the diarrhea, and if that barrier is not maintained, it can spread and cause cross-contamination. And there's a lot of empirical evidence now that SARS-CoV-2 was spread through the drainage system because of the micro water droplets. And this is a drainage system in Greenwich in London under no flow conditions, and we can see the water droplets just suspended within the drainage system, and if they are 5 microns or larger, they can carry a virus, bacteria and pathogens, and if we don't have that barrier to protect us through the water trap seals, we can actually get affected by what we put into the drainage system. So again, in high-rise buildings where you have lots of occupancy people, that barrier provided by the trap seal is important for our health. So, to understand part of the problem, we look at ways of dealing with that. Now, currently, what you tend to use in India is a 3-pipe system. You have a drainage pipe, you have a shared vent pipe, and then you have a grey water pipe for your kitchen waste. So it takes up a lot of space. And we've looked at technologies which we call active drainage ventilation, where we apply products to a drainage system that actively deals with the pressures at the point of need in the building. So what we're doing is, instead of having the relief at the top of the building, which could be 100, 200, 300 meters away through an open vent pipe, we're providing devices at the point of need in the building to deal with the pressures and the transients there that affect water trap seals. So active drainage ventilation is basically a add-on product. In this case, it's a positive air pressure attenuator, and we also use AAVs that we put onto any drainage system to balance the pressures throughout the building. And we know that because we understand the fluids. So we know that we have the fluid systems, that water is annular in the middle, where I said it's 80% air. We're managing the 80% of the air. We let gravity deal with the water flow within the pipe. And then if you're going to get into the maths, it's why the air is moving and the pressure's there. It's the frictional slip between the falling water, the air dragging forward, and this air flow is carried along with it in there. And if we don't replace that air, the pressure increases, and then if the pressure exceeds a threshold of 40 millimeters water gauge, our water trap seals are at risk within the building. So just to give you an example of smoke, where we flush one WC in a building, you can see that it's pulling air throughout the whole system. So every floor, for one 6-litre flush toilet, we're pulling air, represented by the smoke, throughout the whole system into the air action. So again, it's just managing that air in the system. And when we just discharge, we interrupt the airflow from a branch or the base of the stack where we can build up this pressure. And this interruption of airflow with the rate of change will increase a negative and positive pressure anywhere in the building. And if we don't balance that system, our water trap seals are at risk. And where the way we look at that is the speed of change, or the rate of change, is from the oil industry, water supply, building water supply, but also in drainage. With oil pipes, water supply, they're a high frequency pressure wave. Within a drainage system, they are a low amplitude pressure wave, so more like a long wave radio length. So our wavelengths are different, but the principles of fluid mechanics, pressure transfer, are exactly the same as other fluid systems. But when we interrupt the airflow, we cause a rate of change, and we're talking a rate of change in 10 milliseconds. So it's a very, very fast rate of change just by the water curtain changing direction and causing a barrier and back reflection coming up the drainage system. So this offsets, bases stacks are usually the root cause of failing for drainage systems because of the size, the design of how that's done. So understanding what's going on, understanding the water and where the risks are in your design, and putting active devices in at the point of need will mitigate that, just because the change of direction flow within the system. So we can look at that in the base of the stack, just to have a look at flow of water. So we can see that where the change of direction, the water is annular, it falls away, and then we have our hydraulic jump at the base of the stack, and you can see that pulsing, and it actually pulses at 3 hertz, between 3 and 5 hertz. So again, as the sea, if you're on the beach and you see the waves coming in, every 7th wave in the sea or an ocean is a big wave because the frequency of waves are at 7 hertz. In plumbing, we've got 3 to 5 hertz of frequency, and you can see that within the failure of the system if it does change. And if we look at that effect on water trap seals, and again, we're talking 40 millimeters water gauge. If you blow on your hands, you're probably blowing 800 to 1200 pascals of pressure, and we're looking at any trap seal that's seeing 40 millimeters of 400 pascals of pressure, positive or negative, will bubble through or siphon the water trap seal. And once that barrier is lost by that water seal, that trap becomes then the primary trap for venting the building. So if that trap is lost in your apartment, you are venting everybody's drainage system, and that goes in and out of your apartment. So again, this water barrier through a floor trap, running trap, P trap, S traps, is that barrier, that 50 mil barrier is key for our protection of our health in plumbing. And it's a fundamental part of plumbing back down from 1780, moving through Victorian plumbing standards and in the basis of plumbing standards. So it's been a key part of protecting the health of people within the building. And again, we can look at how the traps are lost through evaporation, induced siphonage, self-siphonage, and if we get movement of trap seals, and you can see this a lot in high-rise buildings, it doesn't always suck the trap seal, but it can deplete it over time, and then if you're losing a trap seal and not replenishing it within a week, you end up that trap is depleted, and then you get the smells and pathogens coming out into your apartment. And what we have is, with high-rise buildings in particular, is think of transient pressure for any of you that are electricians, is think of that transient pressure is current and air is voltage, and we know that current travels the voltage, and it will travel in the path of least resistance. So if we have a drainage stack, and we have a 160 drainage stack for our soil, 100 millimeters for our grey water, and we have 75 or 50 millimeters for our vent pipe, the vent pipe is no longer the path of least resistance. And this is, but the standards always say that the vent piping that we put in for your 3-pipe system is always smaller. So it's actually very inefficient for ventilating or relieving pressures in tall buildings. So the taller the building, the greater the risk. And then the cross-fired pathogens. So we know this has been very fundamentally researched. And we know that we need to change the guidance and we need to change the practice for high-rise drainage to the extent that the Chartered Institute of Building Service Engineers are coming out with a new high-rise standard. The ICC, International Code Council, along with the Hydraulic Plumbing Association of Australia, have a working group, the ICC Working Group 185, where they're looking at changing the requirements for high-rise buildings versus the current code guidance. So, passive systems, if you have a building below 10 stories, you could just use a single stack and you need no requirement for drainage ventilation. Then you get into mid-rise buildings, you can use vent pipe. So in India, typically SWR use a 3-pipe system. Then you have systems, again, for a primary wet vented system we call stackerators, which try and interrupt the flow from the branch and also interrupt the flow vertically. And then we have active systems, which we've developed through Aliaxis for high-rise and super high-rise buildings, where we change the need to have the vent at the top of the building to be putting the active devices at the point of need throughout the building. So again, it can do more complex high-rise designs. So what we're doing with an active system, if we take it in terms of sustainability, space, is that we're taking the need to have 3 pipes down to 1 pipe to do the same performance and actually better performance and protection for high-rise buildings. So we're deleting nearly over 60% of the pipe work by just having 1 soil pipe that balances and takes away your waste for an SWR system. So again, it gives you the protection at the point of need. They're designed and respond in 0.2 seconds. So you've got a rapid rate of response. Now, if you take the pipe period of a building like Burj Khalifa, its response time is 5.6 seconds due to the height of the building. And we know that if our response time is less than 0.5 seconds, water trap seals are at risk within your tall buildings. So again, by putting active devices on the system, we balance it out very, very quickly. So we use what we call a positive air pressure attenuator, and we place this throughout the building, typically every 5 to 10 floors. So if you've got a 20-story building, you'd put 3 of these into the building, and if you have a 50-story building, you'd put probably 7 per stack, 7 or 8 of these per stack, depending on the design. And what this does is essentially is a big water hammer arrestor for the drainage system. And what happens is that when we have a rate of change based on the stack, change of direction, we cause a positive pressure. And what it does is it takes that pressure and it attenuates it by inflating and deflating the bag. And we kill that transient speed from 340 meters a second to less than 12 meters a second. And it does that in 0.2 seconds, basically. So it basically kills and eliminates that transient that would travel throughout the system from the base of the building all the way to the vent at the top by actively just putting a device in there that balances and kills the positive transient. And then we can close the system again. So there's a lot of trends, especially post-COVID, of having podiums, rooftop gardens, swimming pools, and we're using space vertically within our high-rise buildings more green space. But what we don't want is sewer vents, open vents near where people are doing that. So we can actually close the system down with the active devices that we're not having any roof penetrations, so you can use these green spaces, and any smells, anything goes in the direction of flow, so it goes downwards out the drainage system. So positive air pressure is if we do it for drainage and water supply, is that the primary medium for water supply is air, water, for drainage is air. The origin of the pressure is the water speed slows instantaneously by closing a valve. So sometimes you get a shock. If you have a shower, turn it off, and you have a flexible pipe system, you can hear it bouncing sometimes, you hear it banging. With drainage, it's the change of direction. So the products that we use in water supply are water hammer arresters, and for drainage, we use a positive air pressure attenuator. But the theory and fluid dynamics and how they work are essentially the same. And then what we use for bringing the air into the system is what we call an air admittance valve, which is essentially a pressure relief valve that opens at 7 millimeters and emits air in one direction, but does not allow any smells or gases to exit the system. And we typically install these in India every 3 floors on the stack. And all that does is it's designed to open at 7 millimeters, 70 pascals of negative pressure, well below the threshold of 400 pascals or 40 millimeters water gauge, and it just puffs a little bit of air to replace the air that's been drawn out as it's sucking down the system. So the combination of a positive air pressure attenuator and an air admittance valve is what makes a drainage system active versus passive. And what this again allows you to do is get rid of the vent pipe, the roof penetrations, reduce the space in the system, and have a better protection for the trap cells as they're being used throughout the stack for unsteady flow conditions. And we've identified right at the beginning that passively vented systems are based on the water capacity. They have only relief point is at the top of the building, so the taller your building, the longer it takes through the pipe period to do there. That the vent pipes are too small to provide pressure relief. They actually have the vent pipe has to be larger than the waste pipes, and complex lines, complex pipe layouts increase the risk of trap failure in taller buildings. An active system is based on the pressure management. It has shorter distances at the point of need. It offers relief as it occurs, and therefore it provides a better protection for the water trap seals to prevent the pathogen spread and smells coming through your drainage system. So, for the architects, engineers, structural engineers, what does this mean for you? Well, currently in India, you use a lot of space for building services, and how much space saving going from a 3-pipe system to a single pipe system provides you for the drainage or SWR system. So you can reduce the amount of space needed to perform the same function for a high-rise building by eliminating the vent pipe and also the waste and soil, and combine it if you're going to do that, or you can keep the waste and soil if you're treating the grey water as well. But you're eliminating the vent pipe requirements, and you're reducing the amount of space needed for your building shaft. So again, we can look at how that is overall the building, what's the maximum space saving. So I've done projects in Canary Wharf in London, and we saved 9 cubic meters of space for a 43-storey building, which in essence made a free floor in cost-wise and space saving with no additional cost by deleting the requirement to have a passive vented system to a single stack drainage system. Again, we can put the devices where they need to be, and on different locations, you're able to save a lot of space. In this case, for example, a 55-storey building, and you're saving on the building shaft space that you would use to carry your SWR system on per floor, and then we look at it per the total shaft space versus a traditional passive system by using an active system. So again, we're reducing the amount of space that you need for your services. So if you're looking for space per floor throughout the building, you're saving a significant amount of space by going from a three-part system to a single stack system for tall buildings. Again, depending on how you lay out your ceiling voids, if you're underslung or overslung, again, for the ventilation that would tie in. Now, I know in India, your branch lengths tend to be less than 3 meters, so you wouldn't need this example here where we have the ventilation on the stacks, but if you have the branch lengths per floor up to 10 meters, we eliminate the need of the secondary vent to go tying back into the vent system. But in India, we tend to put the air admittance valves on the stack every 3 floors. So it gives you as freedom of design. It gives your MEP or your plumbing engineers a way of doing any type of building, whether it's a low rise to a high rise, by actually putting the active defences. So if you change your design, if you have a typical building that's mixed use, where some of it could be an office building, then you have some apartments, maybe a hotel, maybe a health club at the top. Again, with the active system, it gives you a solutions and freedom of design to design how you want to do that, and we make the drainage system, as long as we get vertical gravity flow working for your architectural needs. So again, we get rid of complex roofing. If you have green roofs, swimming pools, and you don't want the roof penetrations, with active drainage systems, we can do that. If you have your HVAC air intakes, you don't want your soil pipe to let out the smells and then recirculate it back into the drainage system. So again, active gives you a possibility with freedom of design. It's pretty easy to install. Here's some examples of the PAPA installed on different systems, and we can do them vertically, horizontally. If we're problem solving it, we can add the units together, so we can solve existing drainage problems, or we can do it as a single system there, and say vertical or horizontal. So again, by having these devices, you've got a lot of freedom in where they're placed, and you can put them anywhere in the building up to 3 meters away from the soil stack. And then an air admittance valve, just giving the examples of how air admittance valves are installed, and more typically the underslung can go vertical, and they just add on. As I say, they allow air in, no smells or water out the system. Acoustics. Active drainage ventilation is where we get a change of direction, we generate noise. So if we have a stack-aerated system, we tend to generate 3 points of noise as it flows, as it tries to slow the flow down. With the active system, we're not interrupting the flow of the system at all. We know that water will fall at 3 to 6 meters a second, terminal velocity. So the discharge of water from Burj Khalifa is the same speed as it is from a 2 or 3 story building. Essentially, the speed of water is at 1 floor drop and it reaches terminal velocity. But if we have a change of direction and we want our soil system to be quiet, we don't want to interrupt the flow. So with an active system, we're not generating this point of noise. And as I said right at the beginning, what we're talking about here in fluid dynamics, it's all part of peer-reviewed research. I'm not that clever to do the fluid dynamic calculations myself. So again, we've got published research here, and if you're a plumbing engineer, I would fully recommend reading The Transient Airflow in Buildings for Drainage Systems by Professor John Swarfield. And we've also got white papers on the Alley Access High Rise website that basically gives you a short 3-page white papers explaining how drainage systems and function and ventilation for tall buildings. Products are all certified. Our Ashvad colleagues make the product, the PAPA, in India. but we have certification from the ICC, DBA, the Australian Watermark, the part of the AS3500, the part of the UK codes, European codes for drainage system, and they're all maintenance free. So they're designed to be installed, and there isn't any annual maintenance on these products. And again, with the air admittance valves, these are sold all over the world, and they have ratings such as Key Mark, NSF 14, CE marks, watermarks, 10 years of warranty. And with the Studer products, they are tested every 6 months with an endurance test of 500,000 cycles, and they're tested at -40 to +65. So again, it's a product that we sell globally. In the US, the Studer brand regularly sell over 1 million units per year in the US market. And Ashavad provides a technical service. So again, if your plumbing engineers want to use CAD, Rivet experience, our engineers and our technical support officers will provide that design support for you. So you can actually look at your drainage system, look at what your plumbing engine is designing, and convert that system. And our engineers are skilled at doing this. And as I say, they've worked on thousands of projects around the world. We're moving to more 3D design systems, so we have a full BIM library, and again with Ashavad, probably has one of the most up-to-date Rivet libraries as well for the plumbing systems, and they can design those and integrate that into your contractor's 3D modelling output, and we can do 3D design and 2D design for drainage as well. So we can give you a layout, takeoffs, and what does it look like? So this would be a typical well, this is in London, a typical conventional passive system for drainage. We can see we've got a lot of vent pipes on the system. And when we go through our design teams, this would be the active system. So it just gives you an example of how we would change an existing design to a single stack design system, eliminating the vent pipes, reducing the amount of shaft that's there. We can give you bill of quantity, competitive pricing, and technical support, not only in design, but also post-installation as well. India, we've got some references for India. This is a project we finished in Pune in 2019, sort of medium high-rise, but again, we've done from the Trump Tower, 86 stories, Nation Towers in Abu Dhabi, Hyatt Hotels in Colorado, Ferrari theme park in Abu Dhabi as well, which is a sealed system, same as the O2. So we've done airports, hospitals, and high-rise buildings for the last 20 years doing these sort of designs. One of the projects we just finished recently is the tallest tower in Greece, in Cyprus. And again, Greece is not known for its high-rise buildings, but this is the start of a trend on building in Limassol in Cyprus, high-rise buildings. So again, we've got a lot of references where we've worked with MEP consultants, major contractors, and how to improve safer space and have an effective, safe drainage system. You can find these references, if you want to, on the AliAxis web pages or the Studer web page as well. And you can see who the designers are, what's been installed there. So again, probably I myself have probably worked on over 5,000 high-rise projects in the last 20 years on primarily SWR drainage systems using this technology. So what does it give you? For engineers, it gives you a simplified design. It's scientifically proven, so it's not a manufacturer saying it works, it's actually peer-reviewed science and fluid dynamics. It works for all types of building types, so from a logistics building to a hospital, to a high-rise building, to airports such as Abu Dhabi, Dubai Terminal 3, Shanghai, Hong Kong. Airports have all used this for their drainage systems, Riyadh as well, just recently. We provide design support services, so again, you can get the support technically on the drainage SWR system, which my colleagues at Ashavad provide through their technical support services. For the installers, it's quicker installation. So you're on average saving about 3 hours per an apartment in man hours in replacing the need for the ventilation. So you can use your labour more effectively than not having to sit there gluing air pipes together, because we delete that. It's a fit and forget, and rectification is minimised. If you make a mistake or there's a change in the design, it's very, very easy to change the design. If you have a wholesaler outlet in your region, you know, you have quality products in your line, you add value-added solutions, and they're high-quality products. They're international products, although we do make these in India. And for the investor, it's cost-effective. It saves you money. It means that your occupants post-install are not getting complaints about smells in the building. So again, you can have wonderful buildings. I've had a lot of these in Abu Dhabi, in the UAE, where you have these wonderful bathrooms with gold baths and all the rest of it. And what happens is it smells, and you get a problem with that, and you get bad reputation. And with social media, and you can go on YouTube, you can go on social media, and then click in smelly bathrooms, all the rest of it, and you see how property values diminish because the building has a problem with its drainage system. So what I'm going to try and do now is just show you where I am in the UK at the moment on our high-rise research facility, which is a 128-metre stall building that's used for elevators. And what we've done is installed a number of drainage systems. And I'm just going to take a quick 5 minutes of just showing you how we test our systems on this test rig in Northampton. Here. So that's me. Just setting up the rig. I'll share that now. Right, so where we're here now, we're just going to give you a quick live demonstration. So where we're here, I'm currently on the 9th floor. So I'm 50 metres up on the drainage system. And what we're going to do is select a number of toilets throughout the system, and we can look at different parts and aspects of doing this. Just give an example of how we test the drainage system. Let's share the screen. So we select a number of toilets, and then share the screen. There we go. Not showing. Can you see what we're seeing? Can't see. I don't know what they're showing. I need to look at the screen. Can someone put the camera at this screen so I can see what you're looking at? Is it frozen? So we can flush the toilets, and we can see from the camera here that we can flush it from the top, the middle, where I'm here now. You can see how the air vent valve works. We can look at the base of the stack. We can have an interaction of... Hello, mate, a bigger tank. Make it bigger.
What, physically?
Yeah. Just want to see that. Okay, so we can look at the flow in the building. We can discharge with an active system, a passive system where we've got soil, waste and vent, or a stacker-rated system. We can do discharges from the top of the building, and we can see how flow moves around the building. So again, as a research facility, as a test facility, having the world's tallest SWR facility, which we host in the UK, we can test all types of drainage to understand, physically see the flows, terminal velocities, solids in the drainage system. So again, we can play around with the drainage system to the nth degree, and we also test, our last test is that we actually break the system and see what systems are like when they're under failure. So that's what 10. That's what I thought. I want to do the big flush. So what we're going to do here is hydraulically break the system. We're going to discharge in excess of 1,000 litres in 2 stacks in 30 seconds, one with an active system and one with a passive system. So again, we're going to hydraulically break the system to see if we get the same effect between an active or passive vented system that we saw in the videos of Burj Khalifa Type A 101. So again, we can replicate that failure and solve the issues. So we're just priming it, and literally it's going to take 1 minute, and then we're done in our presentation. Good to go.
30 seconds.
You want to say thank you?
And then what we can see also on the toilet on the left-hand side, as you're looking at, is the active system. In the middle is the passive, and on the right-hand side, we're not discharging it. But if you watch the flow, you'll see that that is also effective. Because when we talk about drainage systems, we're not talking about individual stacks. We're talking about as a whole building system that's going. Right, so we're going to discharge now. So as you can see, both systems are affected, but with the passive system, if we didn't have the Perspex cover, the water would blow out the toilet about 1.5 meters. So again, what we want to try and do is, even under hydraulic, unrealistic flow conditions, is that we can balance and reduce the failure within the drainage system. So that's the end of my presentation. How do I stop sharing? I don't know how much they saw it. Are we frozen? There we go. They're probably not seeing that. It's frozen. Well, frozen.
It's frozen a long time.
Thank you. All right, thank you, Mr. Steve. That was a wonderful presentation. And I think...
I'm here.
Yeah.
Mr. Steve, are you there?
I think he's logged off.
He's lost. Okay.
Has
Thank
he
you. The
logged
team
off?
is here. We'll talk to them.
Yeah, so thanks to the team who organized this on behalf of Mr. Stephen White, Mr. Dhananjay Reddy, and the entire team from Ashirvad. Can we have them here, please? And may I request VP South Engineer Rajkumarji and Hyderabad Center Secretary Engineer Ramesh Garu to please come onto the dais and felicitate the team for organizing this for us. In the meantime, can I request that will be a commercial break? Can we appreciate them for organizing this for all of us here? Thank you. So next we have a small commercial break. We'll have guys from Ultratech presenting their PPT and their product profile to us. Welcome team Ultratech. And next we will have team from My Home, so please be ready. I'll just slide changer. I just hope you keep it a little crisp due to positive time. How much time would it take? 5 minutes?
Okay, 10 minutes.
5 is fine. 5 to listen. You have to use it from the
Yeah, thank you. Very good evening to all, and hope I'll just try to finish off within very fast because from the online to the physical mode, it's very difficult to understand. I hope, and I'll request you to pay attention at least for 5 minutes. My name is Srinivas. I am taking care of technical service for Telangana, and I'm here to present on the Ultratech Cement presentation. So, if you see this slide, Ultratech Cement is India's #1 cement in terms of volume and capacity, and we are number 3 in China. Means excluding China, we are number 3 in world, and we are in the league of Fortune 500 companies. And the verticals or the business lines, if you see, wherever we operate, right from the stable fiber or carbon black or Vodafone India, we are 1 or 2 the position. So coming back to the mission or vision to the company is that to be the leader in building solution, and we operate in the values. So having said forth, I'll just move forward on the capacity or India's footprint of Ultratech. If you see, we are present across the India. So wherever you go, you can find Ultratech Cement. So presence itself shows the presence, all the capacities here. And right now, at 2022, we are at 120 million tons. And today, if you see, we are at 139 million tons per annum. Coming back to the growth story. In 1983, we started with 1 million tons of capacity. Now, if you see at 2025, we are marching towards, we are trying to achieve 160 million tons per annum. So all these are supported by the extensive engineer support. We got it in the market, especially engineers, consultants, architects from the market, and I would really thanks to all of the team. Now, having said so, we are also moving from a product solution company, product selling to the solution company. So cement is one part, and apart from that, we have started doing a lot of business in RMC, Birla White, everybody knows, and building solution is a concept where we offer a allied partner solution, where a customer can get all the building material in a single stop solution. Apart from that, we are also moving into the building product division, right from cement, mortars, plasters, and all other materials required at a single place from Ultratech offer. And second, we also started a unique platform called Physical and Digital in the name of UTech, where all the partners can come align and work together and offer a solution to the customers. So taking forward, for the RMC also, we are one of the leading players in India, and these are the products, like if you see in the screen, right from the green building solutions and other products also we offer through RMC, and we have a variety of RMC products, conventional concrete to the whatever the variety of concrete required, right from the color concrete to the pigmented concrete and other concretes we offer. So apart from RMC, we have also building Birla White division, where we give a Birla White as a cement as a solution. We have fragrance putty, where we apply, you get a lot of fragrance, like different flavors are there, and also different products for elevation and beautifying your structures. So coming back to building solution I was referring, where you can get a single point entry, and where you can get a lot of products in a single point. Right from it's like to resolve a problem of an individual homeowner, where he goes every to get a building materials. So what I request all the engineers here present, please visit the counters and the places we have deployed so many counters in different districts of Telangana and Andhra also. So wherever you will go, you will find this building solution and you will get a lot of products. So we have associated with a lot of vendors here, like right from, if you see the bottom, like Birla White, you can also, we have a piping solution, we have a pest control solution, whatever the solution required for a single home builder to achieve his dream house, we are there. Coming back to this building protection product division, if you see, we have products in mortars, we have products in plasters, we have also a lot of variety of products in adhesives, and we have also in waterproofing cementitious products. So if you see, if you can visit our stall, number 14 at the start of this entry, you can see a lot of products are available. And these are the products actually are designed with the DIY technology, means do it yourself. So need you to have any expertise or kind of a trained applicator, a normal mason can also apply these products, right? So having said so about UTech, it's a platform. It's a physical or in a digital combination platform where people can come, all the like partners, like engineers, architects, or builders can log on and can just take the, download the app. It's in Play Store and Apple Store also. It's a UTech by Ultratech, and you can register yourself. So this is a platform where connectivity will be easy. A lot of engineers are already have taken this one. What will happen is we can get the information required for any solution for the construction part. So it's an end-to-end solution we are giving, right from design services to the pest control services, solar services, and also rainwater harvesting. So having said so, we are moving from a product to the solution company, right? So many projects we have associated for India and abroad. So for a few projects I just want to showcase, we have partnered with Buildings Nation Pride, right from these three projects. If you can see Atal Tunnel and also airport, T2 airport tunnel in Bangalore. So we also offer not only cement, we also offer the solution by giving the technical services right from the mixed designs, offering a best solution, and also reducing the carbon footprint by doing the RMC, right? So some of the projects, if we can see on the screen, is Atal Tunnel in HP, and Motera Stadium is the world's largest cricket stadium built in Gujarat, and very proud to say that all the concrete was moved by Ultratech. So having said so, all products of Ultratech are Green Pro certified, so it's a hassle-free product, and you can right away can take it. Coming to the sustainable features, like whatever we manufacture, we also take care of, ensure that sustainability is the most core part of ours. Every liter of water we use, we give it to the environment in terms of 4 liters and 4x times. And we also use the renewable energy, right from the waste heat recovery systems. And we also use a lot of the usual or whatever the things are required to maintain a proper ecosystem. Coming to this may be the last slide. Ma'am, you are in the back side, so I'll just not take much of time. You can visit our website, ultratechcement.com, and also you can call to the toll-free number. And whenever you're free, just Google it, Ultratech Cement, you'll get a lot of information. And once again, I thank ACCI for giving this opportunity. Having said so, I'll also thank for your patience, and I think I'm completed in the allotted time. Please visit our stall number 14. We are there to help you out. Thank you so much. Thank you for the patience. Thank you.
Thank you so much. Now I request Chairman Hyderabad Center, Engineer Mahendra Reddy Garu, and our immediate past Chairman of Hyderabad Center, Kashiram Garu, on the stage to felicitate the representative from Ultratech Cements. Mr. John from Ultratech Cements, can we have you on the dais, please? Are we all tired? Yes or no? If no, then we should be clapping. Because we have 2 more sessions and we need to listen to 2 more interesting sessions that are going to come. So thank you Team Architect for your kind support to ACCEI. Now we have a small presentation, an audio file played for MPL. Can you please play it for us, please?
Today, I might be a celebrity, posing in front of 1,000 fans. But this fame, it has not come overnight. It all started in this state-of-the-art facility in Hyderabad. My makers looked for the best raw material, the utmost care with which they did a trial of my endurance, the uncompromising quality standard they have set before putting me here, so that I can make them proud. Strength is in my DNA. I am made from some of the finest iron ores available in the world, such as the mines of NMDC, Chhattisgarh, amongst others. My upbringing ensured that I grew up to be versatile and beautiful. My parents never compromised on anything. They always insisted that the HR coils used should be the best. They always made the best equipment available for me, hired the best professional hands to raise me. I was raised like a prodigy. Do you know, I have to go through fire to prove my worth. Like literally, 1650 degrees Celsius to be specific. It turned me into a coil that can take any shape and form. But being strong is not enough. You got to have the perseverance, and that can only be ensured by constantly going through the grind. I can proudly say that I have successfully passed as many as 40 plus tests before making my way to this shelf. Another important thing is my power to solve multiple problems. That's why I have to take many avatars.
I invite Mr. Srinivas Valluria onto the dais, please. He's a postgraduate in electrical engineering, a fellow of the Institution of Engineers India, chartered engineer, certified energy auditor, senior member in IEEE, ASHRAE, ISHRAE, ISIL, FSAI, IIPA, IPA. He is a healthcare facility design professional, member in National Building Code of India 2016 for fire and life safety. He has established Synergy Infra Consultants Private Limited in the year 1996 and worked on more than 3,000 projects like healthcare, residential, commercial, IT, retail, etc. besides defense projects of national importance. He's made presentation at various forums in India and abroad on energy efficiency and fire and life safety. So, handing over to you, Mr. Srinivas. So, it will again be a 45-minute session, 40 minutes for the session and 5 minutes for Q&A. So, I request both the speaker and the audience to please kindly abide by the time. Thank you so much.
Good afternoon, everybody. You want me to come down? Giving a response? Thank you, first of all, ACCE for conducting this kind of wonderful program. I'm really a bit nervous, to be frank with you, because meeting or facing one structure, why not? I mean, we understand where is the difference or where is the gap. So here, first we'll look at And so when we talk about the buildings, whether it is a high-rise building or a tall building or a regular building, as far as electricity is concerned, it is one and the same. The only thing is based on the type of building, probably the magnitude of electricity or the quantum of energy, what we need to supply may be different. And how do we do that without compromising on the energy losses, so that the building will become more sustainable. So basically when we look at the buildings, we look at adequate power, which is designed based on the overall demand, what is required. So this is the first thing, whatever we do in any kind of building, trying to understand what is the overall demand calculation. And there are different kind of predictions. Unfortunately, if you look at any of our reports, there is no diversity factor specified in any of our reports. So it is all going by the individual's experience. And when I say some 0.6 kVA for 100 square feet or 0.5 kVA, some other consultant may say 0.8 kVA, my friend may say 1 kVA. I mean, I'm just telling like that. So this is how there is a huge variation. So probably some kind of studies which we have been doing it also, probably will help us in identifying what will be an optimized load. And then how do we distribute it over the buildings. So I just would like to tell you 2 or 3 points which are introduced in the recent safety guidelines by the Government of India, as well as the new National Electrical Code 2023, which was released on January of this year, where so far we have been talking about fire retardant low smoke wires. Now it has to be no halogen-free wires. So this is one thing which we need to understand, because most of the cases, whenever there is a fire or there is a short circuit or overload or whatever it may be, one of the things is people will die mostly due to asphyxiation, that is due to smoke. So most of these wires, if they are PVC, they try to give away a lot of smoke. So if it is halogen-free, then probably the intensity will come down. So this is one thing which has been incorporated into the code during the last month which was released. And also, when we talk about high-rise buildings, I just would like to show you something. We have to look at redundancy. I think this is one thing which is highly essential. We can't depend on, otherwise, we have 2 things. How do we do power distribution? Either through cables or something what we call it as a bus riser. There is a bus duct which will be running through and through. And whenever the breaker trips, the whole power will go off for the whole building. So naturally we need to have redundancy. And any building up to 200 meters, generally we can go with LT distribution. But anything beyond that, we may have to go for bus risers and also with redundancy and also HT distribution. The bus ducts, if you look at it, they are highly reliable. The low-cost installation, high current carrying capacity. They can also have fire barriers so that the fire will not spread out from one floor to the other floor, and also high fault handling capacity, and it will have less terminations like cables. Like structural engineers, whatever they follow like E-tabs, we also have something called E-tab for electrical distribution. It's basically called Electrical Transient Analysis Program. So which does the short circuit studies and overload and then relay protection and these kind of things. So the E-tab is very, very important. If you do an analysis, then we try to understand what is the fault level, whether really our breaker is going to trip it on. Otherwise, we can be clueless. I mean, anything can happen. So if you look at a tall building, generally, I mean, if you look at Burj Khalifa, it has got 64 transformers across various levels. We can't distribute the power for a 900 meters or 850 meters building right from ground level, because there will be a lot of losses in the distribution. So naturally, we'll have some transformers at the ground, and then we'll have 11 kV cables which are taken up to the various levels, and the 64 transformers of 1 megawatt range each one are all located at various floors. So naturally, as a structural engineer, we need to take care of all these loads, because they are all heavily, density as far as the floor densities are concerned. And also, these floors have to be completely segregated. Morning, Dr. Suresh was also talking about the compartmentation. We'll also see with respect to fire safety how we can achieve some of the compartmentation issues and how do we protect them. So when we talk about inside the buildings, naturally there have to be no oil should be there because it's prone to fires. So it has to be only a dry type transformer, especially for the buildings. The Indian, the electricity rules are so far now at present it is called CEA Safety Guidelines 2023. They say for any building, industries and all still oil cool transformers are allowed inside a building, but for the high-rise buildings, only dry type transformers have to be used at any level. We can provide transformers even at higher levels, Any commercial building usually which will have a lot of air conditioning loads and other things, it may be worthwhile to have a transformer at upper level, maybe at the terrace or wherever the AC plant is located. Whereas for other type of buildings, depending on the load, probably we can look at a techno-commercial analysis, whichever is right, which is beneficial for the project. And then a transformer should have the required clearances and other things. They are all same, either it is at ground or at upper level. Only thing is the backup power. Because in India we depend heavily on the backup power because of power interruptions and quality of power issues and other things. So that is the reason you need to have backup. But these backup DG sets have to be at the ground level or at the basement level. There is no alternative to that. We can't take the DG sets to any higher level. So then naturally they have to be 11 kV DG sets. And also most of the electrical panels, this is also one of the requirements by the National Building Code, where we need to have a CO2 or halogen-free inert gas extinguishing system, which is connected to the panel. It's not that, either through a direct cable, where whenever there is a fire or some kind of sparking that is happening or a temperature is happening within the electrical panel, in the main panel or in the lifts panel or in the emergency supply panel, we need to have these kind of systems built into the panel itself. So this is in addition to whatever the kind of fire suppression systems like sprinklers and detection systems and other things. And also the recent, the National Electrical Code has also introduced arc flash detection device. So the arc flash detection device, generally we might have heard about a leakage circuit breaker or a residual current circuit breaker. Whenever there is a leakage, I'll tell you 30 milliamps of current for a duration of 30 milliseconds probably cannot be fatal for any person. But anything beyond 30 milliamperes of current passing through a human body for beyond 30 milliseconds, it is going to be fatal, person may die. So that's why the earth leakage circuit breakers are provided for 30 milliamp sensitivity, and if it is around leakage is around 100 milliamperes, then probably an ignition can cause a fire. So that can work like an ignition. So these are some of the things, and another thing which has come out in 2021 is basically the type of cables which we need to use for all these things like fire pumps, pressurization. They're all basically life safety systems. Internationally, the cables are called CWZ, but in India they have introduced the terminology as FWS. So the fire pumps, cables, whatever we use, are for pressurization systems. They have to withstand 950 degrees centigrade of temperature for a duration of either 180 minutes or 120 minutes, depending on the purpose of it. So the F indicates basically the fire withstanding capacity of the cable, 950 degrees centigrade, and as well W is basically fire and water. Generally what will happen when there is a fire, immediately there will be burst of some water poured onto that. We have to have electricity in any kind of building. We can't cut off the whole power for any building because there will be a lot of mechanical systems which also have to work in the suppression of fire and the smoke.
Whatever the time it is specified, and then at every 15 minutes interval, whatever the forces, the mechanical impact is subjected to the cable, so they have to withstand that. Internationally, generally, whatever it says, of course, our code do not recommend any kind of, performance-based designs. But if you look at, because tall buildings cannot be done only with prescriptive basis. It's very difficult because you look at our airport, for example, what code you can follow. You talk about compartmentation for any kind of assembly building with around 750 square meters of compartmentation. Airport is an open area with a lot of people around, and then you wanted to have probably a fire door at every 30-meter travel distance, an exit. It's not possible. So the only thing is you have to look at a performance. In fact, our Hyderabad airport also was done based on that by the Aruf fire, basically based on fire modeling and evacuation modeling. We'll also see some of those things, how that can be done. And then the most important thing where we always come across, with structural engineers and other engineers is earthing. Basically, today the codes, whether it is for earthing or lightning protection, it says we have to use structure as the earthing. We can't do away with that. The ISIEC 62305 for lighting protection, it says very clearly all the columns have to be used as down conductors. And I have come across some of the structural engineers saying that it is difficult for us, something probably may happen if there is a lightning attack, structure may collapse, or something can happen if fault currents are taken through the structure. So that is the reason I just would like to bring some of these points, especially with photographs. And you see, these are all some safety guidelines, like what should be the clearances between these panel boards or in front of the switchboards. And then all metal works inside the building. If you see fire pipelines, water pipelines, which are metal lines, and if you look at hospitals, even including your metal doors and windows have to be earthed. And they all have to be earthed to the building earth. Entire building has to be equipotential. There cannot be any potential difference. They all have to be bonded together, and they're used as, entire building is used as one earth. And then as I told you, RCCBs and AFDD, which is now made mandatory by the National Electrical Code, arc flash detection device. Only thing is we requested our electrical inspector not to insist on this immediately, because a lot of manufacturers have to come into the market for this. But if you do these two things, I'm sure we can forget about electrical fires. I can say the building will be safe the moment you see. These are also mandatory requirements by the National Electrical Code as well safety guidelines of Central Electricity Authority 2023, and also internationally they're all mandatory requirements. And then so earthing and lightning, see, the rest of the things are more or less common. I just would like to tell you this, some extracts from Indian Standard 3043, which is for Code of Practice for Earthing. Not only this particular code, I can show you a lot of references from IEEE and IEC, either IEEE 1100 or IEEE 80 or a green book and other things, so many things. Everything talks about a uniform, the entire thing, all metal things to be interconnected. And here also, this is a ring main basically, which is supposed to be provided in any substation. And this is the earthing of foundation reinforcement. Whatever your column is there, you can see there is a ring earthing pad which is specified, which is connected, supposed to be connected to the earthing grid. So this is what is given in all our electrical codes. And also, it also says NBC National Building Code 2016, the concrete embedded foundation earth electrode is one of the most important. That is the first thing. Basically, when people look at earthing, means to provide two earth pits. But unfortunately, it is not going to help us in any way. Two earth pits will not help, and that is a wrong practice. You are not supposed to have isolated earthings by any of the codes. You take international or national. So only the concrete embedded. In fact, concrete works as a very good resistivity. We look at the soil resistivity. It may vary from 10 ohm meters to around 1000 or 2000, depending on the type of soil. And some of sandy soils, it may go up to 4000 ohm meters, or rocky soils may be up to 10,000 ohm meters. But concrete is generally around 100 ohm meters, and we can also get very good resistance using the concrete. So concrete encased electrode is one of the preferred methods by the codes, and this is how the new National Electrical Code. In fact, this we have been practicing for quite a number of years, but every time we face problems with electrical inspector. Now this is, we are happy that this is part of the National Electrical Code 2023, where it is, the grid of the entire building, the earth, whatever the reinforcement of the basement or wherever it is supposed to be connected to the main earthing terminal, and there's supposed to be number of earth pits like how we used to do earlier. Even now we face problems with elevator manufacturers. My lift should have two separate earthings, otherwise I will not give any guarantee. But even that has been introduced into National Building Code of 2016 under the elevators and escalators, vertical transportation systems, that the entire elevator should be connected to the building earth. So there is nothing called, we are not supposed to maintain anything separately. And also the kind of wires or strips, whatever need to be used as a part of the concrete encased, it could be 10 mm wire that itself is sufficient, which can be basically for bonding to the steel, nothing else. And this is basically one of the basements which has got different earth struts which have been brought out from the raft of the building itself. And then wherever we have isolated footings, That is the earth mat which we have created where there is nothing, and then all these footings have been interconnected with the earth mat, as well as within 20 meters separation, basically for the lightning protection. That is what ISC 6305 says. You need to have a ring conductor and again connect back to the same earthing mat. And I would like to show you some of the damages that have happened due to lightnings. People say the lightning probably will hit only at the top. No, it can hit anywhere. It can hit even, a small building which is next to a tall building. It all, it depends on the quantum of lightning current and the time when it is going to occur. So this is a building, in spite of a terminal third, it has been affected, that particular chimney kind of thing. You can see there is a vertical finial in the second photograph, but still there is a damage that had happened. And, there are a lot of things. And this is a Washington monument where the lightning strike, which was hit at around 40 meters below the top. And why I want to show you is the next diagram, how we are going to do. And this is the Palace of Culture, Warsaw, Poland, where there is 95 meters, it's a 230-meter tall building, tall structure, where 95 meters below the lightning has been hit. So it is not just to provide a finial at the top or something around the building. It is not going to help. We need to have a vertical conductors. So whatever our code says is 62305 or NBC, any building more than 60 meters in height, we need to have a ring conductor all around at the building level, and for 20% of the building height we are supposed to have it, and anything more than 20%, at every 20 meters above 60 meters, we need to have that kind of ring conductors and connect to the building earth. So this is also an essential part, and we have always, recently discussions with some of the buildings is not being done, even though they are all around 150, 200 meters. Commercial buildings is not a problem because you have some kind of a facade glass and then supports and other things which we earth them. That itself is good enough. But in case of other type of buildings, our architects are a bit, this one doubtful that it may not look neat or nice or whatever it is, how to service. But definitely a lightning conductor is required. This is based on ISC 62305, which was also released somewhere around 2015, 2016. And this is how we provide the struts for the whatever the reinforcement, and then connect a strip from there. And this is how we can use the connectors for the earthing strips. This is what we used to do, but now we are using the same reinforcement conductor itself, which could be used with that. And this is how the separate conductor, if you want to take it. In fact, it is all going to be at the same potential, whether it is you are bonding it or not, it is all, the distance between all these conductors is hardly anything, and we are taking support from that, so it doesn't differ in any way. And one more thing that has been introduced into the National Electrical Code 2023 is the arc flash analysis. Arc flash analysis, basically whenever there is an electrical switchgear, there is a possibility there could be an arc flash or an arc blast. For the operators, whoever are there, we are supposed to do this kind of analysis and see what kind of PPEs, personal protective equipment or gear, the people need to wear. So you're supposed to have different color codes where a person, when he is entering into that particular zone, he is supposed to have the required PPEs. This also has been specified now, and we can find out what is the electrical energy at that particular point and then see what kind of PPEs have to be worn by the people. So this is with respect to the electrical safety. I just would like to see some of the things with respect to fire safety of the buildings also. Morning, he has already talked about the building code and then some of the requirements and other things. Any kind of building, you talk about a tall building, it is impossible for evacuation of people from the top to the bottom. It's not possible. Even the biggest snorkel that is available, to my knowledge, in the world is only up to 110 meters. Even our fire department was planning to get one, but somehow they were hesitant. The problem is Chennai and Mumbai fire brigades, they advised them not to buy because they bought it and they are unable to move it on the streets. Because not only the fire loading is around, the snorkel loading is around 65 tons. The problem is we have podiums which are designed for 65 tons, but some of the roads and other things are not for that. So naturally these vehicles got struck somewhere on the way. So I don't think, there is any vehicle which has got that kind of capabilities, because today, Hyderabad, we are talking about, I think, up to 220, 230 meter tall buildings. So that kind of buildings, how do we save them? It's only, the approach is only defend in place. So the only thing is you have to look at compartmentation. So you can shift only people from one compartment to the other compartment, but nothing else. You cannot expect that all the people will be taken to a safe place, because the International Building Code says the people who can be taken to the safe place should be within 20 minutes. So that is where, whenever you are doing a performance-based approach, 20 minutes is the maximum time by which they are supposed to be taken to a safe place. But I'll show you one of the slides, Taipei 101, where when they have done the, mock-up drills after the building completion, it took almost 2.5 hours for them to evacuate the building. And extended evacuation time, pronounced stack effect. Stack effect is one of the major issues when we do the smoke management systems, because what will happen is, depending on the temperatures outside and the fire temperature inside, the air may not go out. Basically, when you try to open windows also, there could be, because the air can come from outside to inside because of the pressure differential, because of the stack effect. So that is the reason we need to use mechanical ventilation fans, and they need power supply in all such cases. And also water supply limitations, greater challenges of mixed occupancies, and probably the building could be an iconic building, and whatever the extreme natural events where fire is secondary, and a lot of fuel is being added to most of these buildings today. We're talking about fuel cells, and we're talking about some of the buildings today, almost around, in a project, we ourselves are talking about 3,600 EV cars, provision for 3,600 EV cars. You can just imagine the kind of batteries that is there, and then the kind of hazard it can create. So there are now guidelines also being come out for that. Morning, Dr. Suresh talked about the fire triangle and other things. I don't want to look at all those things, but the building code, how it has been devised also, he talked about it. We look at, I just would like to tell you one of the NFPA fire risk index, which they have talked about in one of the things, where if you look at it, the weightage, whatever is given out of all the fire safety measures, 77%, other than of course the fuel contents and other things, all rest of the things, almost 70% is related to the building design. So how we are going to prevention of fires, exits and evacuation, significance of fires, and how are you going to close the vertical openings to make it completely safe. So active fire systems like automatic suppression and detection and all is only around 15-20%. Otherwise, the building design itself should take care of the safety of the building. And typical fuel load densities, this is based on NBC earlier, this one, I'll just skip it. I'm sure most of you are aware of it. And one of the important things is when you talk about high-rise buildings or tall buildings, we can't depend on fire pumps located only at ground level. So we also have the code NBC talking about having intermediate level fire tank, around 100,000 liters, at around 150 to 165 meters is what NBC says, but our fire department is insisting on anything above 150 meters, because basically I am also part of the code committee. The reason why it was specified is the maximum installation control valve for sprinklers, generally we get for 20 bars. So you can go up to 200 meters height. So that is the reason 165 meters has been specified as the maximum limit. But since now they're insisting on 150 meters, so we need to have space for these things, and also we have to see the occupants of the buildings are not disturbed whenever the testing is going on for these fire pumps. So we have to make sure that they are structurally isolated from the regular slabs, as well as taking care of the load of the water at that particular level. And we also have an issue of the overflow of water from the tanks and other things not causing inconvenience to the other occupants. And so this is for a 180-meter building. So we suggested fire department, why at 150 meters we can take it at lower level, so that we can optimize even on the pump capacities, which is now today accepted by them. Otherwise, they were going by the code itself. For one of the buildings of 155 meters, they provided fire pumps at terrace. It doesn't make sense. Basically, this is supposed to take care of the building above that, whatever the floors above that. So that is the reason we brought it down to the middle level. And some of the other codes like Middle East and all, they say around 90 meters you need to have separate systems. And the most important thing is you have to look at every building compartmented vertically as well as horizontally. So if you have horizontal and vertical compartmentations, and if you have all services, whether it's sprinklers or electrical systems or air conditioning systems, separately designed for every compartment, then there will not be any major issues. Or otherwise, we need to have fire dampers or fire sealants or something, whichever across the zones when it is going through. And this is for the basements. These are the basically fire compartmentations as per NBC. Morning Dr. Suresh talked about for the basement. So every 1800 square meters for hospitals, and institutional buildings 1125 square meters, and then basements, car parks are used, then it is around 3000 square meters. We need to have a separate fire compartment, which is by the use of having walls with fire doors wherever there are openings, or otherwise water curtains are also allowed in the basement. So that is one thing it says. And most of the other things like, like refuge areas, electrical rooms, AHU rooms, utilities, and then most of these things need to be separately compartmented other than the compartments whatever have been specified. And then sprinklers, you see escalators and other things there could be, they will have openings. So we need to have fire curtains all around those openings, or otherwise at least our code says have sprinklers at least. And this is the typical firefighting shaft. This is derived based on BS 9999. So where you have a lobby with a staircase and also a fire lift, which is used by the firefighters in case of evacuation requirements. So this has to be, if this is taken care, this is only our means of escape from a tall building. We need to make sure that it is completely made of 2-hour fire resistance construction, and there is no fire or smoke getting into this building, in this part of the area. Otherwise, evacuation will be very, very difficult. And the refuge areas, wherever they are there, they are supposed to be connected to this firefighting shaft or fire tower. And this is what I was talking about when Taipei they have done. So this is in between these Petronas towers, the sky bridge, whatever is created to assist the evacuation. Otherwise, they found in Taipei, I believe it's around 2.5 hours of evacuation time. So they started using the lifts across the refuge so that they can bring down the evacuation time to around an hour or so. And fire stoppings, I think we'll skip. I'm not sure the timelines and other things. I can go ahead for some more time. The fire stop, is mostly important when we are making a separation between the vertical floors. Then we need to have fire stops, and the fire stops have to be decided based on the engineering judgments. And they need to have definitely 3 types of rating systems. One is F rating and T rating. The F rating is the time period that penetration of fire stop resists the spread of fire. Similar to any kind of fire door, it is also, like whatever the temperature, the time, 60 minutes or 120 minutes, it should be able to withstand that kind of fire. And also there could be some kind of intumescent materials which will expand in case of temperature, and they try to close the apertures, especially metal pipes or plastic pipes. They may burn, then create a hole. The hole cannot be left open. I just would like to, there was a study done by NFPA which says if there is a room of 20 feet by 20 feet by 20 feet, and if there is a pencil hole opening to the next area, and if there is a fire in that area, this entire cavity of 20 or room of 20 feet by 20 feet can be filled within 2 minutes 40 seconds, 3 minutes 40 seconds. So you can just imagine the kind of smoke that could be generated based on the fire. So that is the reason the smoke sealants are very, very important. And also the temperature rating. Temperature rating to make sure that on the unexposed side of the fire, it should also be restricted to not more than 180 degrees centigrade. So these are, it's for how much time it will reach, by how much time it will reach 180 degrees centigrade is the temperature rating. And also the leakage rating. Leakage is basically in case of, even air conditioning systems or any kind of mechanical ventilation, where how much it is going to be there. And then this is a fire rated assembly, general this one. And one more thing is smoke management. Even though our code do not specify about smoke management, it's only part of the performance-based design, but still some of the projects, some of the MNCs, they insist on this. So what we need to make sure is whenever there is a fire, that particular compartment to be kept completely under negative pressure by taking away the air, and all the other compartments have to be under positive pressure. So the kind of pressure differential also between this floor to the other floors or corridors is also specified when we do the CFD modeling, how much is to be maintained so that the smoke will not enter depending on the fire loading. And once this is maintained under negative pressure, then the smoke will not spread out to the other floors. So this is also one of the most important things when we look at the tall buildings. And the next thing is fire sealants, what we have seen, and fire rated doors. This fire rated doors also was recently revised, IS 3614. The integrity, insulation and stability are the three parameters. Generally when we talk about 2-hour fire rating, whether 2-hour fire rating is only for integrity of the door or even for the insulation or for the stability. All the three could be even different or it could be same. But most of our cases, we generally look at only integrity and insulation. So you can look at, the door, once there is a fire, the entire door assembly has to be intact even after the fire. Otherwise, we also have certain other photographs where the doors have got some kind of openings and they try to fill up with some other materials, or otherwise the door windows are not properly sealed off, or otherwise they make a frame at site and then without testing only a fire door is brought to the site. So it has to go as a complete assembly actually. The entire thing has to be tested as for that. And so you have uninsulated door, insulated door, whatever, different doors, that FD 120 or 180 which need to be specified and which takes care of all the three things. And here, can we have this video? No? This is basically a hospital. I just would like to show you this. This fire happened in Hyderabad itself. Can you just operate it? So what happened is, generally we use a lot of bedded panels. You see, in India, our hospitals are restricted by height only up to 45 meters, but our government of Telangana itself is coming out with hospitals up to almost, 120 meters or something like that. So we can just look at it. The bed-headed panels, actually we don't have any testing for the bed-headed panels. That's what I have noticed. Whenever you have medical gases and electricity power lines taken through the same bed-headed panel, this happened in Hyderabad during last year actually, and in one of the hospitals. So what will happen is, we are supposed to maintain a gap of around 200 mm as per the codes. But the moment you have a bedded panel, the entire panel itself around 250 mm or maximum 300. So there is no such gap and there is no airtight barrier between the two. So it is always advisable to make sure that we go for a proper system. And when you look at performance-based design, especially for the high-rise tall buildings, we have to do a fire simulation using CFD analysis. There are a lot of softwares available like Fire Dynamic Simulator, CFAST and other things, and identify what is the available safe egress time. And during this modeling, we can also understand, based on the fire, whatever the contents of that combustible materials, how much carbon monoxide levels can be generated, or what is the smoke, and then what is the heat release rate. So all these parameters can be found out using the CFD, FDS. And then once it is done, then we can look at what should be the available safe egress time. So by how much time the tenable conditions are maintained. Tenable conditions are basically with respect to three things. One is temperature, visibility, and then toxicity, sorry. Temperature is, unless these three things are within the limits, the people may get affected. So we have to make sure, because the toxicity, like, because of hydrogen sulfide or hydrochloric, different kinds of acids which are generated today with a lot of plastics being used in the buildings, and then the temperature rise could probably cause a lot of harm. And visibility, almost 47% of the survivors, they said they can't see their hands stretched in the thick smoke. So that is the kind of smoke probably it could generate. So these three tenable conditions, if they are maintained, how much is the available safe egress time, and requirement of ventilation based on these combustion gases, and also do an evacuation modeling using FDS again, or there are different type of softwares like Pathfinder and other things which are available. If you do that, I'll show you some models also, and identify what is the required safe egress time based on that. So our available safe time should be more than the required time. And this is a small fire modeling which we have done using CFAST without spray. This is without sprinklers, where the temperatures can go as high as up to almost around 250, 300 degrees. At the lower levels you can see almost up to 500 degrees. The same building, if you do with sprinklers, if it is protected, you can see that the temperature brought down immediately. As soon as the sprinklers are operated, the temperature has come down. This is done for a small building by us for around 30 rooms as a case study. And this is an evacuation modeling. This also you can This is done using the Pathfinder. Can you just, here what happened was, one of the buildings, a commercial building designed by us, was supposed to be taken by an MNC. They insisted on having staircases for the occupancy what they want to have. Generally, our commercial buildings are designed for 10 square meters per person, and sometimes we go for less than, higher than that, up to 7.5 square meters per person or something like that. But this particular client, he said he will have 4 square meters per person. So naturally, our occupancy has gone up by double. Then he wanted us to certify whether our staircases are good enough or not. So this is another problem. You see, we have 2-meter wide staircases, even though for the office buildings where we need to have minimum of 1.5 meters, and staircase width has been worked out based on 10 mm per person, based on NBC. NFPA says 7.5 mm per person. So since he's an American client, we read this. Can you just check this video works, please? Can you just check this? So you can do this kind of analysis and find out right from beginning to the end, once the alarm is initiated, how much time the people can be evacuated to a safe place. So that is one thing. And then each staircase, this is also done by us for that particular case to convince them it is within around 25 minutes, so there may not be any major issue. And we created, of course, additional staircases. Otherwise, it cannot be met with. So this is the thing. And then the egress routes, also it is suggested as per the new codes to have photoluminescent indicators, not depend totally on emergency lighting and other things. And one of the most important things when we talked about smoke management is the flow of smoke. This is due to stack effect, buoyancy, expansion of gases and wind direction, and also air conditioning ducting systems. They can aid or they can suppress even, they can be used as a dedicated or non-dedicated systems. And so based on all these things, we are supposed to take care of the safe routes have to be pressurized or protected. So we have to look at, our code allows having natural ventilation for the staircases, irrespective of height. But as I was telling you, if you do an analysis using the stack effect and other things, we can't do with natural ventilation. We have to look at pressurization of these staircases and protect them. So whatever it says in, this is again, we don't have unfortunately any code with respect to pressurization in India, but we have to follow only some of the international codes. This is from British code, where it says, and how many doors are to be opened in case of eventuality. That also is not specified anywhere. Our code says only 50 pascals in fire staircase and 25 to 30 pascals in the fire lift lobby or fire shaft. The problem is this is only in case of conditions of all the doors locked, closed rather. But in case of any fire, usually where the event happened, as well as at the ground level exit happens, and also maybe 1 or 2 other doors also have to be considered as open doors. So once you open the doors, this pressurization level will go down. So at that time, depending on the type of, different kind of facilities, this is last one is closed where 50 pascals is to be maintained between the outside and inside of the staircase, and 10 pascals in case of doors, 2 doors or 3 doors open. That again we need to specify. Some of the codes they say 3 doors, some international codes they say 4 doors. So we can see whatever is the best. So why I am trying to tell you is, if you design your firefighting, smoke management purpose, whatever the pressurization shaft, if you design it for only 50 pascals when all the doors are closed, your shaft size is only very small, because the amount of air is to be taken care of only leakages around the doors. But the moment you open a door, naturally the airflow required to maintain that kind of velocities up to 0.75 meter per second across the door openings is quite huge. So the shaft sizes vary. So whenever we design certain things, a lot of discussions happen, why you need such a big shaft, why can't it be smaller? Some people are talking about only small. So this is because there is no code, that is how it is done. But we need to look at logical relations and also consideration how many doors are to be kept open in such a case. So basically the staircase pressurization we can do single injection or multiple injections, especially tall buildings where you have service floors, you may have to do even from service floors level, because we can't pressurize the entire staircase for a 500 meters or 300 meter tall building. So you will have a fan at the top or at the bottom, whatever it is, wherever it is open to the air. And also the shaft, whatever it is there, where the air intake should be away from any kind of other shafts, because otherwise sometimes it may pick up the smoke itself. And then probably if you have a fan at the top and there is the fire or smoke which is coming to the top, it may pick up the smoke and then it may again put back into the shaft. So that is the reason you are supposed to have a fire damper as well as a smoke detector. And then with all these things, this particular shaft and this thing is to be protected. So if you see our fire shaft arrangement with a lift lobby and staircase and pressurization, and also look at having RCCBs or arc flash detection device, I'm sure our buildings can be made completely safe. There is nothing to worry, but only thing is we need to also understand how to control the pressures and while designing the system. Because if you, most of the cases, some of our people, they say, we can't have any service floors, because every square feet matters a lot of money for them. So if you see in Hyderabad, I have seen any building 200 meter tall having a service floor, except one building what we are doing. Other than that, nothing. They say, okay, one apartment we'll give it, you use it for, as a facility, whatever you want to take. But I think we need to get into the same international level, when we want to do buildings like at the international level, I think even our systems have to be to that particular level. So this is what my presentation. If you have any questions, I would be glad to answer some of the things. Thank you very much for this nice opportunity for me. Thank you.
Thank you so much. That was really a nice presentation, and thank you so much for keeping the time as well. I think that was one of the most wonderful things I would like to thank you for. Audience, in case there are any questions, we just have one more session to go, and then, it's all free. We are all available in the hall. We can network, we can ask our questions, and we can continue. Sir, one question I'll take, that's it.
Hello. Sir, I have one question.
No, we can't put any earth pits in the concrete, because the problem is there is also a possibility of water oozing out, from the basement.
If at ground level we do the earth pit.
No, you provide an earth pit at outside your, whatever the basement or whatever it is. Beyond that, you can provide an earth pit.
But earth pit should to be filled with concrete. What, according to you, now the concrete will have more?
No. Concrete is has got a better soil resistivity when compared with a lot of other soil. Oh. But it doesn't mean that all earth pits we try to fill up with concrete. You use the building itself as an earthing purpose.
Okay.
You need not have separate. Only for the purpose of testing the earth resistance, if you want to have a test pit, you can have a pit outside that particular zone.
Hello, sir.
One question, sir.
Yeah.
But as you pointed out, I'm here.
Sir.
This way. Yeah.
Yeah, please.
As you pointed out, yeah. I'm facing a problem with the Schindler lifts, sir. Actually,
I'm facing problem with every lift manufacturer, every hospital equipment supplier. Every day we have a fight.
Whatever, how many pits I am providing, they say that the resistance is not sufficient.
Sir, I'll tell you one thing. Here, if somebody talks about resistance, please tell them very clearly. Yeah. There is no relation to resistance at all. Yeah. First of all, earthing is completely a different thing. People, those days have gone. People talk about 1 ohm resistance, 2 ohm resistance. None of the codes specify any kind of resistance. But it is only earth loop impedance, fault loop impedance, which is supposed to be measured, and then make sure that our protective devices are in working condition.
Okay. But what they say is they refuse to give guarantee.
Correct. But see, tell us, we'll fight with them, because see, I'll tell you, there are enough codes today, Indian codes itself. I'll tell you one of the case of an MRI, one hospital, the equipment supplier, which is coming from US basically, they said, unless you give me 2 earth pits, it will not be safe for me. The problem is, naturally the doctor told me, it's costing 4.5 crores, why are you talking about 20,000 rupees, 2 earth pits? It's not the question of 20,000 rupees. When I asked him to show me the manual, he brought a manual which is modified in India. He put a sticker there to be having 2 separate earth pits. When I asked him, when the original manual came from US, it says very clearly, it should be connected to the building earth. So, you see, even in case of lifts and elevators and other things, the code very clearly specifies, NBC 2016, it can be connected to the earth mat. You need not have separate earthings and separate things.
Thank you.
Srinivas,
yeah, all right.
Srinivas, can you please highlight tall buildings, car charges? Any codal provisions?
Yeah, I'll tell you, I think maybe I'll take 2 minutes of the time. I think that's okay, I hope. See, what happened is today, when we're talking about a lot of buildings, and EVs are becoming very reality. I think we all should accept that. And also Government of India is giving a lot of subsidies and other things. So we, along with ASCI, we formed a committee, along with Electrical Inspector, Fire Department officials, and Transportation Department, and ASCI, and the government. And we were also part of the team. So what we have done is we have brought out the draft guidelines. As per the guidelines, I'll give you synopsis of that. Now that is with the government. Anytime the GO may be issued. One of the things is EV chargers up to 7.2 kilowatt can be installed at any basement level. The Government of India has come out with, because there were a lot of apprehensions, and also our electrical inspector has given a statement, we will not allow any cars in the basements. If you don't allow any cars, then it's completely against the government policy and initiative. So we have discussed with them, and finally what has been agreed is the batteries today, after April 2023, they are tested as per the new standards issued by the Government of India. And battery manufacturers, earlier they were getting batteries from China, everywhere else. We don't know any of those standards, none of the test certificates. Now the batteries after April, they have to be manufactured in India, and they are witnessed and certified every month by ARAI, Automobile Research Association of India from Ahmednagar. They have to go to their premises and test everything. So that is the reason today the batteries are safe. When we discussed all these things along with the ARAI, then finally our electrical inspector is convinced that we can allow cars up to the any basement, irrespective of any level. Only thing is up to 7.2 kilowatt. Only thing is, because today what I see is bigger cars like Benz or BMWs, they are also asking about 22 kilowatts three-phase. So that is not allowed as on today. What we thought is we'll allow this 7.2 also, they can charge. Only thing is it may take more time. So we'll allow it for next 2-3 years. Based on the response, we thought we can increase it further. And only thing is, every car location, wherever you have EV, you need to have a smoke detector, even in the basement. That is a mandatory requirement by the safety guidelines of Central Electricity Authority. Again, it's from the Government of India, and that has to be followed. And second thing is, all car parking areas should have sprinklers. Sprinkler water is the only thing as far as the NFPA. It's around 10,000 liters of water is required for extinguishing one car battery fire. So that is what they estimated. So we need to have sprinklers, and considering it as a high hazard area, that is being already done in most of our basements. Only thing is for buildings like 5 floors or 3 floors or something like that, those basements we may not have sprinklers, but they need to have a hydrant line or something from the water supply tank itself. That is what the code, the guideline has been incorporated. So it has been made very friendly. I think there will not be any issue. The EV chargers can be allowed. And of course the EV chargers, it's not just a charger in the sense that we need to have EVSC. It's called Electric Vehicle Supply Equipment. It is as per IS 17017, it will have all the protections against overcurrent, short circuit, reverse power, earth leakage, and then earth continuity. So all these things are supposed to be monitored by EVSC, and it can cut off the power in case of any kind of difficulties. And these EVSCs are also supposed to be weather protected, because there is a possibility of sprinkler water or something splashing onto the chargers in case of testing or leakages. So these are the guidelines which have been included into that. Only in case of assembly buildings like malls and multiplexes, they are not allowed below ground level, but the only thing is in the first basement they are allowed again, but with a separate compartmentation, 2 or 5 compartmentation they are allowed. So other than that, everywhere it is allowed, and this will come out hopefully shortly.
Yeah, so thank you. I'll not take further questions. So please step forward. Mr. Valluri is in the front row. You can talk to him, because for our valedictory, Minister Prashant Reddy is expected any moment. I do not want us to lose out on the last presentation that we have for today. So thank you so much, Srinivas Garu, and thank you for the patient audience. And I request Ramesh Garu to please take over.
Please take back here, sir.
Yeah.
Now I request Architect Marshall Strabala and Architect Chetna Jain, please come on to the dais and do the facilitation to the speaker. Thank you.
Now we have a small commercial break. May I request representative from My Home Group to please come over?
Yeah. Yes, ma'am. Can I take?
Yeah. So you have a audio,
Yeah, I have
or you
this.
want a presentation?
This one is okay. Presentation. Can I start?
Sorry. Yeah. Strictly 5 minutes, please.
Respected NATCON organizers, Association of Consulting Civil Engineers, esteemed delegates, and ambitious entrepreneurs, please accept my namaste to you all. Today, as up to the topic of the seminar, Building Tall, we, on behalf of My Home Group, are here to present you India's going to be the tallest precast tower. Before I take you into the project, let me give you a brief about My Home Group. We are in operations last 3.5 decades in Hyderabad, Telangana. We have completed 24 residential and commercial projects. About 35 years of rich legacy we are carrying, and 33 million of square feet of the total built-up area is handed over to the happy customers. And over 17.21 million SFT is under construction, and over 10 millions of SFT is in planning stage. We have achieved a lot of excellence awards. Few are like Most Trusted Developer, Most Best Integrated Marketing Campaign, Kradai Telangana Reality Awards, Greatest Brands and Leaders Award, Best Real Estate Company of the Year 2016, and Quality Council of India's Platinum Award for Quality. These are few landmarks of My Home projects in Telangana. My Home Avatar in Puppalguda, Outer Ring Road, Skyview, Gachibowli, My Home Bhuja, My Home Navadvip, My Home Taraksha, My Home Tridasha, My Home Krish, My Home Mangala, My Home Ankura. These are few of the landmark projects. You all are here to give something to society. We, on behalf of My Home, are here to take all your services from entrepreneurs, consultants, and all of you. So using all your support, we have initiated the project called My Home Grava, which will be the tallest commercial precast building in India, having 98,000 precast elements, which will be installed in each phase. One phase have 2 towers and 1 non-tower area. Largest tower cranes are used with a lifting capacity of 50 tons with a tip load of 12.5 tons at 70 meters jib. The non-tower area is equal to 1 individual tower area. And the project is already pre-certified for LEED Platinum building, and project will to be implemented in the BIM framework only, Building Information and Modeling. This is the aerial view of the project. We have total 8 towers. Now phase 1 is tower 10 and 20, 2 towers. Each tower is 7 basements, lower ground, upper ground, and 34 floors. And non-tower has 7 basements, LG plus UG. Overall built-up area of 16.7 million square feet, and super built-up area 28.9 million square feet. Currently, the phase 1 construction is in progress. Sorry. This is the landscape view of the towers. These are few logistical elements. We have total 6 tower cranes. The movement of installation. So we are using BIM. Yesterday, one of the initial speaker was talking that designers are working in silos. This BIM is allowing us to work as a team, and we are able to avoid any clashes in the design as well as the execution. So now we have gone up to 5D, and also, one of our project we are using 7D for facility management.
So it's time.
Can you just play the video? 1 second. Okay, then.
We've moved much beyond the time, so please understand the paucity of time.
1 minute. Yeah. How are we achieving the quality? You can see. Can you go back?
So,
can you switch on? Can you switch on that?
How much time does it take?
Just 1 minute. 1 minute. Only 1 minute.
There's a lot of paucity of time. That's the reason why.
Yeah.
Yeah. Thank you so much.
Thank you.
Now I invite our MC members, Engineer Jayaprakash and Engineer Bhanuprasad Garu onto the dais to felicitate the representative from My Home Group, please.
Thank you very much, sir. Thank you all.
All right. 2 long days, so many wonderful sessions, commercial presentations, and we come to the last session of the 2 days of NATCON 2023. And the last topic for today is vertical transportation in tall building structures, presented to us by Mr. Gopakumar. Can I request Mr. Gopakumar to please come onto the dais? He's a graduate electrical engineer from University of Kerala, joined vertical transportation industry in the year 88, worked with a couple of major multinational companies, ThyssenKrupp and Otis, till 2013 in various capacities, overseeing their sales, installation and services in southern India, working as a professional consultant for architects, builders, consultants and developers in areas of traffic study, ride design, procurement, execution and inspection of elevators, escalators and moving walks. Has an overall experience of about 35 years in the field of vertical transportation. So heartily we welcome Mr. Gopakumar to take over the presentation. Over to you, sir.
So good afternoon to all. I think I'm sure that most of you are very tired after the hectic sessions today. In fact, I am in Hyderabad after probably around 5-6 years. So when I was traveling from the airport to the hotel, I could see the transformation in the skyline, in the infrastructure, the developments all over the Hyderabad. It was quite amazing. As an elevator person, I was more interested in the vertical transportation systems provided in all these tall buildings, because basically elevators are lifelines of any tall buildings. You just imagine a condition when the elevators are not working in whether it's a tall building or even a high-rise building or a mega tall building. Just imagine for 1 second what will happen if the elevators are not working in that particular building. So this plays a critical role in any tall building. So we had a lot of sessions and a lot of talks were made on elevators also, not in detail. So the vertical transportation system basically consists of 3 things. I am referring to the passenger movements: elevators, escalators, and moving walks. And today we will be focusing on the elevator part only. So I'll just take you to the history of elevators, some small presentation on that. This elevators or some form of lifting mechanisms all were invented with the birth of cities. So when cities were born, public buildings, palaces, monuments, all these were constructed. It was necessary to lift some or to have some lifting mechanisms in all such buildings. Then the coming of the culture, Babylonians, Egyptians, Greeks, etc., the Tower of Babel, Ziggurat, pyramids, all these tall structures of those days wanted some kind of lifting mechanism. Then the steam engine, invention of steam engines, the reduction gearing system, the hydraulic, water hydraulic, oil hydraulic, then the age of electric power. So these all contributed to the invention of some lifting mechanism. Probably the figure what is shown here may be the first lifting mechanism reported by, it is invented by Archimedes before Christ in 236 BC. It was not for the transportation of human beings, it is just for the transportation of materials, some kind of a lifting mechanism for the transportation of materials. The safe elevator safe gentlemen. So with that, the elevator history starts. The first commercial elevator was installed in the year 1856. The speed of that elevator was just 0.2 meter per second. Nowadays, even a home elevator has a speed of 0.3 or 0.4 meter per second. There are different classifications. I'm not going to details of all these things. We have freight elevator, passenger elevator, hospital, then the automobile elevator, dumbwaiter, with the different types of drives like single speed, variable frequency. So when I talk about the drive, when I started my career way back in '88, we had a couple of more drives at that time, like 2-speed, then DC VV, that is DC variable voltage systems were there. But of late, these 2-speed systems, DC VV, AC VV, all these systems have gone into history. And now mostly variable frequency, variable voltage, VV-VF systems are in place. Regarding the doors, we have automatic and manual. I think still in some parts of the country, the manual systems are in place. But most of the places it's only automatic doors. Except for the industrial purpose, the manual doors are not permitted. We have control systems like simplex, duplex, group supervisory control, destination selection control, etc. This is just a reference to the skyscrapers of the pre-war area. In those days, the building, this Eiffel Tower, Empire State's building, all had a lot of elevator installations in those particular buildings. And according to today's standards, these were all over-elevated buildings. The purpose of having elevators in the building is to have a waiting interval of 30 seconds or less with a handling, reasonably good handling capacity. Before I go to traffic study or the impact on the buildings like that, I just want to share a couple of my experiences in the elevator industry. These two, I will share two experiences. These two are related to hospital buildings. See, in one case, a hospital building was designed with all the elevators, most of the elevators as 15-passenger stretcher lift, with 15-passenger stretcher lifts. Then, because those days the preliminary or the pre-design meetings were not there, at that time I was working in the industry. So we all were called for negotiation or tender evaluation meetings. At that time we suggested that this 15-passenger elevator will not help you in a hospital. So the building design was frozen. The work also started there. So then what they did was that two 15-passenger lift hoistways were made as a single one, and they converted that into a 26-passenger hospital elevator. The rest all were 15-passenger elevator. So the hospital was commissioned. So whenever someone goes there, or any passenger or any patient, they have to be in the queue for minutes or maybe 10 or 15 minutes to get an access to the elevator building. They would be forced to demolish at least 10 rooms of that particular hospital. Then they said it is not possible. We cannot give you that much. Then they abolished or abandoned that particular project. But still, they were finding it really difficult with all the crowd there in that particular hospital. So after some years, finally they shifted their reception or the front office to some other place. They constructed another area with the structural arrangement. They installed another 4 lifts. This is one case. Another case is that it's a running hospital. Enough number of elevators are there, and they were constructing another new hospital in the same city. I don't want to refer to the hospital, that's why. So before constructing the second hospital, they wanted us to do a study of the first hospital. Because the first hospital, the issue is that they have enough number of lifts or elevators, but all the departments are complaining. The doctors are complaining that they are not getting a dedicated lift for them. The stores department is complaining that they don't have whenever they want to shift the materials or they want to ship the medicines, they have to always take it in a trolley and deliver to the respective floors. Then we did a study, and then finally we told that the elevators always start at different locations. There is no signage. And instead of creating a proper, what you call the good lobby or elevator lobby, all these things were scattered in that particular building. So these two cases I am just giving you as a food for thought before I go into the importance of traffic study. Till a few years back, till that time, people were not very much worried about the number of elevators or what kind of elevator should be installed. I'm not, with due respect to you, sir, it is the case in India where I am talking in most of the cases. See this, how the traffic movement in a high-rise building impacts the business of that building. There is a big impact on the commercial aspects because in case it is an over-elevated building, definitely you will be losing a lot of space of that building. You have to spend a lot of money on procuring the elevators, so you have to incur a lot of expenses on maintaining those elevators. If it's an under-elevated building, it's a pain. You don't find any takers for that building. The upper floors will not yield you much business, or will not generate much business. So any building, any tall building or any high-rise building or even a small building itself should have the adequate or the right number of elevators in that building. So I already mentioned the space utilization. The space is very expensive. So if it's an over-elevated building, the space will be unnecessarily wasted. So the client, ultimately the client will lose a lot of money. So at a later date, I told the first case of I gave some food for thought. In that one, I told about one hospital building. Any additional unit is expensive, and locating the space is very difficult. The objective of a traffic study is to find out or propose a system where the handling capacity is within a reasonable limit. I'll just come into the terminology, handling capacity and waiting interval and all, and with a acceptable waiting interval. Handling capacity is known as the quantity of service. That means during the peak period, what percentage of the peak population is handled in that by the entire elevators installed in that particular building. The quality of service is connected with the waiting interval. That means once a call is given, how long we have to wait in that particular lobby to get the services of the elevator. So the other considerations are traffic flow, the up-peak traffic flow. So it is not the up-peak alone. Sometimes it will be down-peak during the lunch period. All these things will be taken into consideration. The group operation, the population of that particular building, etc. Initially, this was applied for offices. Later on, it was applied to almost all the kind of buildings like residential, shopping malls, hotels, airports, etc. In case you referred BAS, this is the simple calculation or the simple formula available there. It's round trip time divided by the number of lifts. T is the waiting interval. Imagine the round trip time is 100 seconds and the number of lifts are 4. Then the waiting interval will be 25 seconds. The simple equation, but the complexity, it is very complex to find out the round trip time. The factors affecting the round trip time are the door open time, the door close time. Just imagine when the lift is starting, the door opens, someone enters, the door closes, it moves up. That means the passenger entry, the passenger exit time, the acceleration time, the deceleration time, the speed of elevator, the floor distance, the floor-to-floor distance. The lift may not stop at all the floors, all the stops. So the average number of stops. It need not go to the highest, the topmost level for a floor, the reversal. So the average, the highest floor at which the elevator reverses its direction of travel. So this depends on so many factors, and then finally we arrive at the round trip time. With regard to the handling capacity, the equation is very simple. 300 into Q into 100 divided by T into P. That means 300 refers to the handling capacity during 5 minutes. Q is the average number of persons carried. P is the total population to be handled during the peak hours. The round trip time is connected with so many factors are affecting the round trip time. It is not the speed of the lift alone. 5 seconds. Waiting interval achieved in all these cases is much below that. That means 13.5 to 10.6 seconds. The handling capacity decided is for an office building, it is around 10 to 15%. So this was a major issue. So the handling capacity we got for the first 3 cases, that means case 1, case 2 of option 1 is 8% and 8.8%. Option 2, they were 9.2% and 10.2%. That means we just reached the bare minimum requirement of 10% plus with case 2 of option 2. So the average waiting time achieved, that means waiting time is achieved is 52 to 42 seconds. Average time to destination from 93 to 76 seconds. So in this particular case, we suggested the case 2, option 2 with a speed of 2.5 meter per second, 16,000 kg capacity with full destination selection control system. Destination selection control, I will come into the later part of this slide, my presentation. These are some of the recommended elevator layouts. So because we have seen we will be seeing a lot of elevator designs. Some desirable plans are the bank of 4 elevators in a row. So, or a group of 6 elevators facing each other with a distance of 3.5 to 4.5 meter. Then a group of 8 elevators facing each other, 3.5 to 4.5 meter distance. The 2 banks facing, one is the low zone, the high zone kind of arrangement with the 6 meter or more. The plans shown below are undesirable plans, because in all these cases, the passengers waiting in the lobby will get confused. Zoning of elevator, to some great extent, we have heard a lot in the morning presentations. So these are here, the diagram represents 3 zoning of these elevators. Elevators in a building to different zones. The low-rise, mid-rise, and high-rise zone, because we have already seen why critical the traffic study is. Now, the next part will be how we can improve the waiting interval and the handling capacity by different means. Zoning is one of the means for that one. So the large group is split into different zones. It will be low, mid, and high-rise zones. So in all these cases, the number of stops will be fewer, so the transit time will be reduced. So because of that, the upper floors, normally the upper floors will fetch good rental rates. So when the transit time gets reduced, you will get better rental rates. But normally for the hotels, this zoning is not much recommended because the guests it will be convenient for the guests to have a single elevator group in the hotels, and also in the hotels special elevator escalators for the banquet halls. And elevator lobby, it is recommended to have a space big enough to hold at least 50% of the combined maximum capacity of all the elevators. Next one method is the shuttle elevator. Shuttle, of course, we know that. Shuttle passengers, for shuttle buses like that, it's a means of travel, a frequent journey between two places. It moves from the lobby, between the lobby floors at high speed, from the parking to the main lobby. These are all high capacity and high speed elevators. So this all will allows efficient travel within high-rise buildings. So this is a representation of shuttle elevator in a building. The other different zones are also shown there. Now we come to the next part. These are taller and smarter buildings for the future. So in the first part, we have discussed about how we can improve the waiting interval or the handling capacity of lifts in a building, because there the concern was on the passengers to be transported or transferred to the upper floors in a building. This is one particular product which is invented of late for improving the construction efficiency. These are jump elevator is one installed in a regular elevator hoistway. When the building is progressing itself, this will be installed in the regular elevator. So from the diagram, it will not be very clear because there are some videos. If you you can find a lot of these videos in the YouTube, because these are patented products of companies. That's why I don't want to play those videos, because each company is having a product of their own in the jump elevator segment. The height of the elevator, you can see here, you can see a platform. The upper deck is there. The upper deck protects from falling objects. This once one particular floor of the building is raised, then the guide rail will be installed. The machine room as a whole, it will jump to the next level, and machine room will be locked there. So these are all self-climbing elevators, some hydraulic kind of arrangement, all having different arrangements. Hydraulic kind of arrangement is there. The machine room goes to the upper floor. It locks there. The upper decks are protected from falling objects. Now, see, normally in the earlier days, only construction hoists were in place, mainly to carry materials. But along with that, people also used to travel in those particular hoists which are all of very low safety or hardly any safety in that particular this one. Later on, construction elevators were in place. This is used against construction elevator, the present construction elevator in any tall building. We'll just compare with the construction hoist for the jump elevator. The construction hoists are exposed to atmosphere. whereas the jump is installed inside the building. The climatic condition has impact on the performance of the construction hoist. This is not having any impact. Construction hoists are low speed. This is 6 to 8 times speedier than the construction elevator. The safety part also, this is jump elevators are much more safer. Faster transportation of materials and manpower. The traffic capacity is increased by 300%. Manpower is better utilized. The construction efficiency is improved, and the return on the investment is very faster. So this, when the high-rise or very tall buildings are coming up in different parts of the country, this will be an alternate for the construction hoist, because construction hoist is exposed to atmosphere, and the climatic variations all will have an impact on the performance of the manpower as well as the equipment. So I didn't want to go to the challenges of this slide. This has already been discussed much in detail by many of the many of the people who have presented their papers earlier. So this all, I don't want to go into details further. So elevated and high-rise buildings, these are the issues to be taken care of: the piston effect, the building sway, stack effect, etc. These also were covered in many discussions earlier. The piston effect is in single shaft. The air displaced is pushed to the narrow gap around the car. So this is a representation of that. When the car is descending, the car on the side is compressed. So it moves, it creates some kind of a noise level also. So I don't want to go into the design aspects of all these things. The building sway is already discussed in detail. Stack effect also is discussed. So these are the innovations for the intelligent elevator systems of the future. I already discussed about this destination selection control. The normal dispatcher, the normal control system, there will be what you call the master, and there will be slaves. Like that kind of an arrangement is there. The master will assign to the slave to which floor the system should go and pick the passenger waiting there. This is a control system wherein you have a keypad or a touch screen in the lobby. So you can key in, or you can just press the button, the floor designation where you want to go. So immediately it will assign you to assign a particular elevator in that particular bank, and you can go and wait in front of that specific elevator instead of waiting in the lobby. So the people will move from one elevator to the other. Instead of that one, you can move to the elevator specified by the destination selection control system. So the efficiency in this particular case is very high. Then another one is double-deck elevators, which already discussed. These are the twin kind of elevators, two lifts in one shaft itself, both lifts one over the other. Both are having independent control system, independent machinery and all. So here you can see the second diagram, one core is removed. Actually, instead of 4 units in 4 cores, here 5 units in 3 cores, like that. Another one which is the latest invention is the multi, where a number of units will move horizontally as well as vertically. So these are not using any guide rail kind of an arrangement. The power is transferred between the shaft and the cabin. It moves vertically and horizontally, multi-level brake systems These require smaller shafts. The usable area is increased by 25%. These are the latest inventions in the field. So this is a case study. I don't know. I think this is the time allotted me. Then I am having only 5 minutes more. This is the case study of a high-speed elevator installed in Guangzhou, South CTF Finance Center, where the world's fastest elevator was installed by, that is at 20 meters per second. So this required some special kind of a drive system. The 330 kilowatt permanent magnet synchronous motor was required. Similarly, a control panel, a very big control panel was required. So different techniques were introduced for reducing the elevator car vibration. Accelerometers and actuators were allocated for different points of the rail system. Different systems were adopted to reduce the noise in the elevator car. So when the speed increases from 10 meters per second to 20 meters per second, the noise level increases by 15 dB. So different, the source noise reduction was used. Then a streamlined capsule that reduces the fluctuation by approximately 50% was in place. It was tested in a wind tunnel, and actual elevators verified that techniques had succeeded in reducing the internal noise. So when you travel in high-speed elevators, there will be sensation of air blockage. Air pressure control system was used to reduce the impact on your ears. This kind of a simulator was used to replicate the changes in the air pressure in the elevator. Special safety features were in place, like the brake. Special brakes were developed. So because when the brake is applied, it will be as hot as almost 400 degrees Celsius. The safety devices, which required almost 4.8 times the braking energy. Laminated ceramic wedge was used. Oil buffer for 20 meters per second. The oil buffer size requirement is almost 24 meter. So this, they reduced the size by using a telescopic kind of an arrangement. Certain different construction techniques were in place, like delivery of fully assembled traction machines, joint assembly of test elevator car prior to installation at factory, guide rail construction techniques, then simulation of evaluation trials on-site and off-site, etc. So emergency terminal speed limiting device monitors were in place. I'll come to the last part of my presentation. These are about green elevators. So now most of the technology what we use nowadays, it's gearless technology, where the gear, it is a gearless machine will be in place, so the oil, the lubricants or the oil will not be there. The coated steel belts, there's a couple of manufacturers are using the coated steel belts. The regen drives where the additional power which was dissipated by using the brake system was fed back to the system. That means when a lift, lift with which is fully loaded system is coming in the down direction, or an empty elevator is traveling in the up direction, the energy generated is driven back to the system, which is used for lighting the cabin lights or fans, etc. So disabled and friendly features for the car. So for remote monitoring systems, then region drives VF technology, and so you get some 1 point. For construction waste management, most of the waste generated by the construction in the construction sites are either scrap material or it can be either reused or recycled. So up to 2 points you can get. Certified wood, if it is certified wood, then 1 point is there. Low emitting materials for adhesives and sealants, 1 point is there. Similarly, for the low emitting materials for paintings and coatings, 1 point. These are some of the tall building projects which we are associated with. So my time is up, so I'm just concluding with my presentation. In case you have any doubts, you can either contact me on phone or you can send me a message in WhatsApp or in my email ID. One more thing, we have a quarterly online publication called Elevator Digest. If anyone is interested to get that particular magazine, you can just get in touch with me. We'll be pleased to give that information. Thank you very much.
Thank you so much. I'll request Engineer Harikumar from Rajahmundry Center, Chairman Harikumar Garu from Rajahmundry Center, and Amarnath Babu Garu from Rajahmundry Center to please kindly come onto the dais to felicitate the speaker. So please center stage.
I think
Thank you. That brings us to the end of all the presentations for the last 2 days. And as per our schedule, we have one last thing to do, that is the panel discussion. So it's left up to you all in the hall. If you think that we should go ahead with the panel discussion, looking at the time, we'll definitely go ahead. It's all up to you. So how many hands go up for the panel discussion?
Yeah.
I just don't see any hands go up. I guess everybody's exhausted. So, sir, I just have 10 hands go up and half of them are the speakers. I want the audience for the speakers now. Okay, so.
No.
Okay, so we'll have a quick panel discussion, maybe just a crisp one for maybe 10 to 15 minutes. Whichever questions are left out or somebody has not asked any question, this is the time, please catch up and we can have the discussion. So now I would request all our speakers who've been with us for the last 2 days to kindly join us on the stage. Professor Jeff, Professor Ong, Marshal Strabalaji, please. Professor Norang, Darshanji, so this is the time. All of us who missed asking questions or due to paucity of time, whosoever, I could not allot time for asking questions or you missed out on asking, this is the time for all your questions to be answered. So please get ready.
I request the delegates to raise the question to the specific speaker, please. One second. Balram garu mee dariki vastunaru. Mics, please be ready.
Hello.
I request all the speakers to please settle down.
This question is for the PMC presentation paper. Please kindly talk about the concrete handling at higher levels and any blockages in the pipeline faced. If so, how they were mitigated, and what is the percentage of wastage of the concrete? What is the wastage of the percentage of concrete while handling the higher levels?
So the question was addressed to whom?
Anybody can answer.
Dr. Ong? The BMC.
Project management concern.
The PMC paper.
I told in the beginning
I think
only.
it was Dr. Naran. I think that is addressed to him, the PMC paper.
Anyone can answer. What is it?
You mean for concrete at the high level, right?
Yeah, while handling the concrete at higher levels, were there any blockage? And if so, how you could mitigate it? And in general, what is the percentage of wastage of the concrete? And there will be a number of vehicles ready. In case of blockage of the pipeline, then entire concrete to be wasted, no? And any segregation problems found? Any segregation?
He says that when you're pouring concrete from greater heights, it might not slide down. There could be a blockage of the concrete. And there are also vehicles lined up with the concrete ready to be poured. So in such a situation, how will you mitigate this risk? And what is the measure you would take?
So, I just catch the occasion. We can do two things. If we pour concrete at high, we should use the trimmy pipe. This is the first thing. To avoid the segregation of the concrete itself. The second, if it was blocked by something, we have to increase the workability of the concrete by increase the slump. You look like when you pour the concrete for the ball pie, you will use the concrete slump around 7.5 centimeter plus minus 2.57 centimeter, right? Very similar concept. Am I answer your question?
This is to the professor. I found a swimming pool is constructed on 3 towers of a hotel in Singapore. That is for dampening the structure, I was told. To the professor I am asking. In a Singapore hotel, about 65 floors, a huge reservoir is built, and the water reservoir is built that is being used as a swimming pool on the top of the 65 floors. And it is technically implemented. That's what I was told by the builder, by the people there when I visited. So what is your opinion about that, that idea of using as a dampener?
Okay. If I understand correctly, the question is about using swimming pool as a sloshing water damper.
Yes.
Well, when you have a swimming pool, the water in the swimming pool can slosh. We can calculate the first mode, sloshing. We can calculate the sloshing frequency. If the sloshing frequency does not match with the natural frequency of the building, it will not work. Okay? First thing is the sloshing mode frequency have to match with the natural frequency of the building. The second point is the swimming pool needs to dissipate energy, because in order to work as a Joule mass damper, it will absorb energy into the sloshing mode, and it has to dissipate energy. If it's just a normal swimming pool, it cannot dissipate much energy. So summing up all this, normal swimming pool will not work as a Joule mass damper. So if I don't think it will work.
It is not a normal swimming pool. It is a very massive. I wish you have visited that.
Well, if you have a water tank,
yes,
and you put many Y mesh into water tank, and you design the dimension of water tank such that
yes,
the sloshing mode frequency match with the natural frequency of the building.
Yes.
And you have enough Y mesh in that, it will work. But then the sloshing water damper will occupy a lot of volume because the mass density of water is low. If you make it like a pendulum or the one that I proposed yesterday, you can make a mass in a form of concrete or steel. Then mass density is about 2.8 ton per cubic meter or 7.8 ton per cubic meter. Then the damper will be more compact. But if you make from the water, the mass density is about 1 ton per cubic meter. It will occupy a big space on the top of the building. And it's very difficult to maintain. So I don't think the sloshing damper is a good idea. That's my own opinion.
It is existing since long time. I wish you have observations on that. Thank you.
I myself have a research paper on this one too. But I don't buy the idea.
Yeah, good evening. Myself, Krishnakant Reddy. I am from metal craft forming industry. I have one query related to fire rating of the material. See, for a pre-engineering buildings, fire rating generally asking for 2 hours. So, for a built-up sections or any plated sections, we have a intimacy paints which can control for 2 hours. But for roofing and purlins, secondary members, what is the chances like we can go for 2 hours fire rating, which we cannot control for sleek members, 2 mm thick or
yeah,
1
so,
mm thick.
so Mr. Krishnakant, the person who had dealt the subject fire, Mr. Suresh Narayana, I think unfortunately he's left for the day. I will still ask the honorable panel if they are able to take your question.
Yeah.
So this is a question on fire. He says, can you just repeat your question?
See,
quickly?
the recrystallization temperature for a steel, it is 600.
Any of us here is equipped to take recrystallization temperature of particular fire for the building that he's asking? His question is regarding fire.
I understand that.
Yeah.
How about what is the
increases the fire temperature? Intumescent paint.
Yeah.
Very expensive and sometimes doesn't work.
When fire is reaching to the sheeting part, for any pharma industry or any...
Can you come forward, please? Can you just come forward?
Yeah, I'm talking about an industrial building.
Yeah. Please come in front.
Yeah. For industrial buildings like PB buildings, the fire when it is catched, for a hot roll members or a built-up sections, we can control by intimacy paints. But I'm saying when it is reaching to the roof, where we have a 2 mm thick and 1 mm this 0.5 thick galvanum sheets, which we cannot how we can control fire rating. Means before 2 hours only it will be catching fire and it will be
Fire ratings are usually based on thickness of whatever your fireproofing material is. If you use drywall or dry lining, the more layers you put on, the more you have. A 1/2 inch drywall will give you 30 minutes. An inch drywall will give you an hour. 2 inches of dry lining will give you 2 hours. So the thickness of your fireproofing material will increase. The time rating before the fire will affect the piece you're worried about. Now, if you're talking about a roof,
yes.
How many floors is the building?
No, it is a picture roof. Picture roof. It's similar to.
Okay.
I understood it's an industrial building, right?
Yes.
It's a 4 meter or 5 meter height you're talking about?
Yeah, exactly.
6 meter, fine. You are putting the galvanum or GA sheet or aluminum sheet as a roof or corrugated sheet as a roof.
Yes.
Without any insulation.
Yes. Maybe insulation also.
Okay.
It will ease.
What I suggest, you put a cement board, fiber reinforcement cement board first, and you take the fire rating from the fiber cement board manufacturers. Then you insulate it for your roof thermal transfer values. Then on top of it, you fix the sheet. It can give the 2-hour rating or whatever, depends on the board and combination, full combination of the building, the model assembled. You got it?
But the cement board we cannot use for this roofing.
No, people are using. All airports are fiber cement board used as a base layer on the roof below. Then they insulate it. Then they put a roof sheet on top.
Okay.
Yeah, you can use a rock wool also. Rock wool, see, if we compress rock wool for 33%, gentlemen.
Yeah.
Okay, any more questions? Yes.
Yeah.
Please.
Good evening, everyone. This is question to Professor George Choff regarding the soil investigation and foundations.
Okay.
Sir, my question to you is, for calculating the soil bearing capacity, we are still using ultimate theory. Why we are not using limit state theory?
I'm sorry, I didn't get the question.
Can you repeat the question, please?
My question to you is, for calculating the soil bearing capacity, you have shown me a formula. After that, we get ultimate carrying capacity. To it, we apply a factor of safety of 2.5 to get the safe bearing capacity. This theory is based on ultimate theory. But my question is, why still we are using ultimate? Why can't we have a limit state theory in soil mechanics also?
Okay. So he says we are using the SBT test of the soil bearing capacity to understand the bearing capacity of the soil. So instead of continuing with the conventional SBT method, why can't we use the limit state method for the soils also?
Ma'am, it's not STP. I'm talking of SBC.
He calls it the soil parameter test, and we all call it the soil bearing capacity as the SBC.
No. It's different.
Yeah. So I'm just trying to put it that way. Why can't we use the limit state method for the analysis of the soil as well? That's his question.
Okay. All right. Thank you for your question. So, first of all, yesterday when I did my presentation, I emphasized that it's very common in people still use SPT values to do the estimation of the bearing capacities, which is it's the most convenient way geotechnical engineers will get the data. But my point, the point I'm trying to say yesterday is we do have a very good knowledge about calculating the bearing capacities. For example, the equations I showed yesterday, those were developed based on the limit equilibrium methods. Therefore, those equations involving the determination of the cohesions, friction angle, you are able to determine those numbers from the lab. So what I would like to see is in our geotechnical engineering field, we start doing more testing in the field, getting the samples and doing the laboratory testing in the lab so that we can determine the soil properties to be used in the bearing capacity equation. So I really want to push this. Instead of using SPT values, let's use the actual data for the soil, for the rock, for the bearing capacity calculations.
Sir, I'm asking about that equations only.
Step forward.
Hello?
There's a little gap. There's a little gap in the pronunciation, so I mean, it's not reaching properly. Please step forward.
Sir,
please come ahead, so it's easier for me also to comprehend.
Sir,
or you can write the question on a piece of paper also.
I'm okay. Sir, I'm asking about the equations. The equations are being derived based on ultimate capacity. Am I right?
The bearing capacity equation was derived based on the limit equilibrium equation, is what you're saying?
Those are the ultimate capacity of the soil for those equations.
Those were, well, if you're talking about Tazaki's bearing capacity equation, then it was developed based on the limit equilibrium methods, which talks about the balance of the forces. And in his development of the Tazaki's equation, it involves some assumptions. For example, Tazaki used the strip footing in the development of the equation, and also Tazaki assumed the soil underneath the footing goes very deep depths. It doesn't have any influence on the footing load, and those kind of assumptions make the calculations of the bearing capacity very conservative.
You mean to say those equations are conservative?
Yes.
And to that conservative, we are again applying a factor of safety to arrive the allowable bearing capacity? It is too much conservative then?
Yes, we are very conservative in terms of determining the bearing capacity using Tazaki's equation. However, because of the unknown we are facing in soils, that's why we are still using the high factor safeties. And that's the part I'm trying to say we could try to improve. We can build more economical foundations by knowing the soil mechanics, by knowing the laboratory tested results.
Okay. And my second question...
Does that answer your question, sir?
Yeah.
Yeah. Others who have a question, I have a small suggestion. If you can put it down on a piece of paper, I think I will slowly read out and then they can comprehend it better from here, if that works for all of us. You can go ahead with the question. Any other question, please write it down on a piece of paper along with your name, please.
Yeah, my second question to you, sir, again. In tall buildings, we have uplift. In tall buildings, we have uplift load. So how do a foundation engineer stabilizes this uplift forces?
Okay.
And adding to that question, what is the allowable settlement in uplift? Uplift for soils.
Where's the uplift force coming from?
Okay. In the tall buildings.
The water pressures.
No. It's due to wind. It is due to wind.
Due to wind load.
Yeah.
I understand what you're saying. The earth wants to spit everything out. It's like shoving a boat in a swimming pool. It wants to pop out.
Yes.
And you could use friction piles or tension piles to keep from doing that until the weight of the building's on top of it.
If it is a shallow foundation, I'm asking about the shallow foundations. As isolated or a raft. Maybe sometimes we may mobilize it with
That's a little more dicey. I would not be too conservative. I would be very conservative on that.
Okay. Can I add? Can I add some more information about the uplift? In the shallow foundations, if you have the lateral loading, like wind or earthquake loading, if we have uplift, we allow the uplift in our analysis. But we have to, in our analysis, because of that uplift, the soil stiffness needs to be ignored in that uplift area. So the foundation tension resistance due to soil will be ignored, and on the compression side, the bearing pressure will be increased. So we have to simulate according to that uplift scenario. So on the compression side, if the bearing capacity is still adequate and the foundation is still stable, it is okay. Regarding the settlement that you asked, normally we check the settlement for the particle settlement around 25 to 30 millimeter.
That settlement is due to the compression load?
Yes,
or a
settlement is
behavior.
due to compression, yes.
I'm asking which is in the uplift, just trying to...
uplift, we do not measure explicitly, but in our analysis also we can check from our analysis model, if the foundation is uplift, how much vertical displacement upward occurred. So it should be around 25-30, same as the compression side.
Okay. And my next question is to the wind tunnel. My third question is due to the professor of wind tunnel explained about. Sir, my question is, your presentation is very good, but maybe my question could be wrong for you. But the question goes like this: what are the errors and accuracy of wind tunnel test?
I know. I know the question, but I do not know the answer.
Sorry, sir.
Yeah, that's a good question. Basically, to understand the error, you have to compare the wind tunnel test result with the prototype measurement. You have to measure wind pressure, wind force in the real building. But that kind of measurement is so expensive. So normally no one, just a few cases report this kind of measurement. So we still, but based on the few reports that we have, is matched well with the wind tunnel test result. So in the practice, we actually believe that the wind tunnel test can predict the prototype behavior well. Okay. In the future, I think what we should do more, I mean, the structural engineer should try to convince your client more to install sensor into your building, your structure.
Yes.
By
So
that
those-
way, you will learn more from your structure.
Those are structural health monitoring systems.
Right. It's not just only checking the health. We will be able to check many other things. Yeah.
And my second question, sir, what important parameters to be checked in the reports? For example, because we don't do any wind tunnel test, so we get a report from the wind tunnel inspector. So what important parameters do you suggest us to look in before we conclude on those reports? Any
actually,
guidance you can give us on that?
Well, wind tunnel model test is to provide, to support the structural designer. When we conduct the wind tunnel test to check the wind load on the structure, the wind tunnel team will translate all the test results into something that structural engineer can use, like equivalent static design force, and then they will send this to the structure designer. Structure designer then can do their job, but wind tunnel testing team will not help you in designing the structure. It's just providing you more accurate data about wind load.
Yes, sir, I understand that, but my point...
Sir, I have a small request. Can you please jot down your question and send it to me, because others are losing out on the opportunity.
Gentlemen, we are, you have a lot of patience. We understand. We appreciate your patience. Only my request is, they are also since morning along with us. So any last one or two questions, please raise your hand, and relatively, please ask one or two questions.
Yeah. Otherwise, the mail IDs
Yes,
are already
this gentleman,
shared. You can write.
Satrayana.
This question is to Penang, Mr. Professor.
To whom you are addressing?
Penang.
Penang.
Regarding base isolation, my question is?
Satrayana, I request Penang will come down. You will be there for 1 more hour. He will talk to you if you don't mind, please. And we all asked our questions. They gave their presentations. Now I request all the speakers to give their response about this event.
Yes.
Hosting of the event, about this event, one by one, in a 1 minute, kindly. I request all the speakers to give your response about the event and about your experience in India as well as with our audience. ఫోటో అంటే సిగ్గు సత్యనారాయణ గారు ఎలా ఉంది మా టీము నిండుగా ఉంది సార్ సత్యనారాయణ గారు మిస్సారు వాడు కూర్చున్నాడు గారు మీరు కూడా రావచ్చు మాకు గురువులు మీరు రండి 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 సత్యనారాయణ సార్ కదా ఏమనుకుంటారండి ఓకే ఓకే పర్ఫెక్ట్ ఫోటోగా ఉండాలి అందరికి మేము సేవ్ చేసి పంపిస్తాం ఆర్కిటెక్ట్ సురేంద్ర గారు రండి ఫాస్ట్ ఫాస్ట్
Thank you all the speakers for your kind gestures and joining us. Now I request Chetna Madam to take over for the further proceedings of the valedictory. Yeah. I request all the speakers, if time permits, kind attention speakers, Mahendra Reddy garu, Darshan, all of you can have the posters we prepared, the old tall buildings, ancient tall buildings of India and new tall buildings. Just have a glance if time permits to you. All of you, all the speakers, I request. There are two people who are there. Manjusha, Joshita and Lakshmi did a great job in preparing all those things, compilation, all those things. President Chairman Garu, please, they did a great job. All of you can see ancient tall buildings and the new tall buildings. I request Chairman and Vice President West to please join them in giving the here, Vice President West, here. Please give them the memento.
Thank you very much. We'll be in touch.
We'll be in touch.
Yes, thank you.
Have dinner together. You're going? Yeah, Arupton.
He's got a long trip to Chennai. They go through Delhi.
You have lives with electricity. Joshita, taken, na? Photograph is done? Great job, great job. Now I hand over the mic to the MOC for the valedictory function.
Kedra madam, आप ऊपर आना. Thank you. Be there. We have all dinner together.
Okay, so we say all that begins well, ends well. So I think we can take the privilege of saying that we started on a very good note and we are closing on a very nice note. There could have been some flaws, some shortfalls, but yet we made it through all of these. So I think we can all cheer for all of us. Hip hip hooray. Thank you. And so the last pleasant task of the valedictory function the closing ceremony as we call it. So I invite our treasurer, Engineer C.H. Narmada Garu, onto the stage. Narmada Garu, wherever you are. Secretary Ramesh Garu, Vice Chairman J. Bhimrao Garu, immediate past Chairperson Kashiram Garu, Chairman Mahendra Reddy Garu, Vice President West, Engineer Puneet Raiji, Vice President South, Mr. Rajkumar Kacharla, onto the stage. Please occupy your chairs on the dais.
Where is the President?
And request our Honorable President onto the dais.
Vice President West 2123.
Yeah. So, Vice President 2123, Sandeep Shirkedkar ji on the dais, please. Ramesh Garu, you're needed on the dais. Okay. I'll request Engineer J. Bhimrao Garu to give his closing message as the host Vice Chairman.
2 minutes Bhimrao Garu ekku maatladante mic ni.
Thank you, Madam. Namaskar to all. ACCI National Bearers and the ACCI Hyderabad Center Bearers, sponsors, speakers, exhibitors and other dignitaries present. I am very much delighted to give the valedictory at this International Conference on NATCON 2023. We know that conference attendance is a life with a dissipation of knowledge and wisdom. This connects many professionals together to share their views about a particular topics and themes that were just concluded. It gives opportunity to the conferences to share their views in a particular topic. It builds confidence in the technical professionals and students and help them to learn from one another's experiences and innovations, which is in turn help the technical professionals and students to apply such innovations in their work field. We have reached today the end of today's international conference, NATCON 2023 on tall buildings, with various questions raised and discussed along with the part of subtopics. According to the Swami Vivekananda, great is art of beginning, but greater is the art of ending. With this, I can see great recognition, influence in the future for the ACCI Hyderabad from all over the globe. Thank you very much. Namaskar.
Okay, sorry for the delay for the first time throughout the 2 days. Remarks by our President Engineer Vijay R. Sanap.
Good evening. I can feel the energy now. I will not take much of your time. We are almost at the end of the event. What a great show, NATCON 2023. It has held new records as far as attendance is concerned, as far as the quality of event is concerned, the speakers, the sponsors, the exhibition, everything was great. And the show is hit. My congratulations and big thanks to the hosting center, Hyderabad. Thank you so much. I'm sure all the attendees of this NATCON 2023 will take this event in their memories, and they will cherish the memories for the year to come. We are going to have another show, NATCON 2024, next year. We'll keep you updated on that. I'm really thankful to all of you for being so patient, and you are here till the end of the event. Thank you so much. Thank you once again.
Yeah. All the exhibitors, I call the name. Please come and accept a token of remembrance. Make it fast. Thank you for all of your support. And Srinivas, really amazing, Srinivas Jupaka. Amazing. Please come. All of your support only made this possible. This event is successful because of you. Hope you got good response from our delegates and also other people. Definitely we'll ensure that whatever the best we can do, we'll do it for your business increase. Thank you for all of your support. Next, Madam is open here. Next, Hindustan Waterproofing Company. No, andaru vastunar. Yeah. Next, Hindustan Waterproofing Company. Next, Modisha. Next, Dwarka, TMT. Next, Dextra. Next, Nanospan. Shankar, all the photographs should come very clear. They are important to us. Sri TMT. Civil Labs. Vishwa Ishwani. DS Max. NVS Energy. Nice. Birla Shakti. One by one. Please, because your photo is important to all of us. Please come, sir. Nice. Please come from right side, go from left side, please.
So Civil Tech Labs.
Sorry. Civil Tech Labs. Nice is going on now. Next, Birla Shakti. Kindly move forward, please, because we should have at least minimum audience in the hall. Birla Shakti. Next, Civil Tech. Nanospan. Okay. Yeah, I'll tell. Nanospan. Vishwa Ishwani is over. Sri TMT.
CTMD, Rajiv, next event you will be only sponsoring. We will not ask anybody. Rajiv only will sponsor from CTMD next event. Only. Thank you. Birla A1. Birla A1. Birla A1. Kindly make it fast. Surana Wires. Birla A1. Next Surana Wires. Mir Birla A1, huh?
On behalf of Surana.
Oh, Surana. On behalf of Surana, our Hari is accepting. Vaishnavi. So this is, what is that? Kirby. Vaishnavi. NVS. Yours, sir? Minitech? Minitech floors. Yes. CMAC. Minitech floors, please join. Your company. Swabiman. Okay. Swabiman. Kirby, I called you, no? Yes, Kirby. Yours, sir? Oh, I'll mention about you and call.
Actually, stall was, cards were there, each and every stall existing, but it's done over.
After confused out CMAC, NCL Group, DS Max Ochara,
Sorry.
KBR Ochara, Rara, Rendamari. CSI, software company. When I called them to sponsor this event, really I came to know it was shocking, the words from them. Dear Raj, many people use this software in India, ETAPS, but we are very not happy that most of the people will not buy from us and use. Then I said, that is definitely, we will try to do it because our business also is growing. So CSC, first time they gave a sponsorship in the form of a stall in India. CSI, thank you very much. Convey my regards to Satish and Rajiv and Hemant. Thank you. And all the MC members, one by one, please come. Please say.
Sir, నేను పోస్టర్ దగ్గరికి వస్తా ప్లీజ్.
రండి ఎందుకు పికప్ అవుతారు అనుకుంటున్నా. ఓకే. Before organizing company members, I request, because of whom this event is successful. She is an architect and also a great compeer and masters of ceremony for the last 2 days. I request Dr. Chetna to come and accept a token of remembrance from SSC India. Please allow me to join your photograph.
I request all of you, give the big round of applause. Thank you.
Thank you, madam, for your valuable time for 2 days. Thank you.
Sir, for calling me.
It's official, you know. Thank you. Now I call upon all the organizing committee members. Manasa, please join and accept a token of remembrance from us for your support. She was very helpful to the Chetna in performing her duties. Thank you, Manasa. Manasa is none other than our Dr. Rangarao's great daughter. Kani. Okay. Good advice. Adi madam no, Narmada madam no, aladi. Unta. One gentleman, my uncle, who made this in all our endeavor and journey, is really, we pressed him like anything to do in the nights, days, you know, how much trouble we have given him. Uncle Abhishek Reddy, the son of only Mahendra Reddy, come and accept a token of remembrance from us, our president. Uncle, I will not trouble you, uncle, now. I will come. He's a proud father. Thank you. Thank you, uncle. Thank you. Now I call upon the names. Please come and accept token of remembrance from our president. Organizing chairman, Mahendra Reddy. A token of remembrance to our newly elected and appointed Vice President West, Punit Rai. And Center Chairman and the Organizing Committee Secretary, this gentleman never sleeps and makes me sleep. A very troublesome man. Thank you, Kashiram, and congratulations to you for our compliments to you for a great work under your leadership. We enjoyed your leadership. And Center Secretary, these are the cherishable moments to people who work very hard and it is great success. Our chairman is almost in tears now. That is the response of all of yours. Organizing Secretary, Joint Secretary and Secretary of the Center, Bhimrao Garu. This gentleman, a great personality and a perfectionist, I'd say. He wants everything in a perfection, and I don't think in the last 30 days he must have slept only 5 to 10 days. A great perfectionist and asset to this ACC India. I'm telling ACC India, my dear friend Ramesh, the treasurer. He is always within the youth. He is having a big fan following in our ACC. Now, a lone lady in the team who worked very hard along with the team members with lot of responsibility and commitment and dedication. C.H. Narmada, now incoming chairman, treasurer. Next, the great advisor and a critic inside to make the things perfection. Mr. C.A. Prasad is here. If anybody is outside, please call him inside. By the time I'll ask other people. Whatever the technical presentations I have seen, this is the effort of the team, but this gentleman worked very hard, day and night, that so Rangarao Garu, please. His immense time and his efforts made these 14 presentations a wonderful feast to you. Thank you, Rangarao Garu. And also one more gentleman along with him always guides us and tells us. Balram Garu and Krishna Reddy Garu, please join us. These are the 2-3 people always, they criticize, who have to better for improvement, for the betterment of the fraternity. Thank you, Krishna Reddy Garu, and as well as Balram Garu. For your support, and the next event we want minimum century. Thank you team Warangal. All the people, Anna. Come. In the center, join in the center. Thank you. The chairman of the Warangal Center and his team, Ali. Ali is planning another 4 to 5 centers to open in this region. Ali, it's a promise, right? Another 4 or 5 centers from your hands we are inaugurating. It's a promise from Ali. Thank you. Siddipet and Mahabnar already initiated and more centers in the pipeline. Thank you. Ali, it's a promise, na? See, commitment. Now, I request, whatever the food you enjoyed and the way it was served without disturbance, the 3 members team, 3 musketeers, day and night they worked and made this possible. One of the musketeers and our new MC member, Mr. Banu Prasad, please come and accept token of remembrance. And later, Jai Prakash, though Amar is not a member of MC member, but he worked very hard for this event in the food committee. Please come. Thank you, Banu. They're all our future leaders. The new MC member, 2325. Jayaprakash, 2325 MC member. And MC member Sushil. Professor Bhishma, MC member, is not here. I request Mr. Panduranga to accept on behalf of him and give it to him, because he stays near to him. And also Mr. Panduranga. This is for the Bhishma. Small. For you. A simple story. When we announced this, MC said, our Chandrasekhar Garu said, no, I may not attend. But, you know, a person, a visionary, a doctor, encyclopedia of the civil engineering, attended this event and spent 2 whole days. Thank you, MC, for this wonderful gesture of yours. It motivates all of us, and thank you very much. And Sudhir Akkala, Sudhakar Akkala. And all the organizers, please come and stand nearby the dais. All the organizing working committee members. MC, please come on to the dais. No, a small token of remembrance. Please come. Please come. All the organizers, please come near to the dais. No, not MC members. Was taken, no? You're taken, no? A token of appreciation. A token of appreciation. Please, MC, come join. MC, Randy. Come, you can join. Thank you, MC.
Audience, I'm accepting.
Great audience. Thank you, MC. Shrikar, Sagar, one by one, please come. Anvesh. Yeah. Dinesh. Sagar. Sagar. Organizer. Sagar. Kartik Chari. Anusha. Anybody is missing, please come. Your efforts to be recognized. Sir, the names on the back side of the brochure, please come on to the dais. The memento which you are seeing is designed by two gentlemen, C.A. Prasad Garu and Rangarao Garu, with their team. Thank you, Rangarao Garu and Prasad Garu. Marshal, can you come a moment for the on stage, please? I know it's troublesome for you. This gentleman architect wanted to receive it from you. Architect Chetna, please, you also join. To give this, honor this gentleman as architect. No, this gentleman architect. He's architect. Come, please get. Marshal, you can be on the stage, not a problem. Yeah. Anybody left? Anybody left over? No? Anybody? Okay. Yeah. We are ready to, we are ready to accept your token of remembrance. Please, 1 minute. Okay? Yeah. The event managers, the team traditions, led by Aaron and Mahalakshmi, please join on the stage, accept a token of remembrance for event. Well organized. You made our headache less headache and easy. You made wonderful arrangements. And this is a token of remembrance from us to you. And you keep on serving us like this, definitely we'll keep on giving you business. Thank you. Please join. Take first accept. Arun be there. Mahalakshmi, please join. Nasima, please join. And Shankar, you alternate arrangement, you make it. Otherwise, you have to take the memento now. Nasima, be there. Be in the photograph first. Yeah, first, after we'll take. Marshal, they did really hard work, make this possible, you know. Yeah, we appreciate their efforts. Thank you. The photographer, videographer, Shankar and team. Thank you, Shankar. Now, I request the AIT team to come and do the present task. AIT team, Ong, please come. Ong. Uncle, Ong ni paiki teeskara uncle. Mementos istarada AIT nunchi maaku. Innunte anni paiki rammanu. Ong, please come on to the desk. Where is the pimentos?
Uncle, you call them. Cup the uncle. Be careful while going, you know, so many people are admiring you.
Oh no, they may catch you here only. Mahendra Reddy. Sandeep. మన రమేష్ గారు. Within the youth, young man. Bibra garu. Kashiram garu. VP West, Punit Rai.
VP South, Rajkumar Garu. Last and final, President Sir, Vijay Sanap Garu.
Yeah. Arctic Chetna, please come and join and take the remembrance from AIT. Now I request Krishna Reddy Garu, please come and accept token of remembrance from the AIT. Balram Garu next. Rangarao Garu next. Har Krishna Garu. Fans, Kotandra Babu. Music and a bit in there, Marie. Rangarao Garu is one of you. Come on. Dr. Rangarao. Thank you, Ong. Arctic Shobala, please accept a token of remembrance from the AIT team. Marshall, please come. Marshall, we'll come down. We'll come down. We'll come down. Please come. Last. I know it is a little challenging for you. I understand. Thank you, it's over. There are closing remarks. Now, closing remarks are there. Audience is not there, so I'm not speaking much. Thank you, one and all. I bow my head in front of all of you for your support and encouragement. Now, I request the Secretary of ACC Hyderabad Center to propose vote of thanks quickly. Where is Manindra?
Where is Manindra? Please come on to the stage.
Hey, Abhishek.
Mani, please come.
Chaturvedi, why you miss?
Mani, please come. Please, quick. There is no time.
Chaturvedi from the AIT team, please come on to the desk. Please. Accept program.
Shankar.
Chaturvedi is the back-end man of the AIT team. Come, Chaturvedi. Ramesh Sarkar photo call, join in the fans.
Thank you.
Now all yours, Ramesh.
Yeah. Respected Presiding Officer Engineer Vijay K. Sanap, President ACCI, and other dignitaries on the dais and off the dais, distinguished guests, fellow fraternity, ladies and gentlemen, a very good evening to all. It gives me immense pleasure to perform the pleasant duty of proposing vote of thanks for these 2 days seminar. On behalf of ACCI Hyderabad Center, I convey our sincere and profound thanks to Engineer Vijay K. Sanap and ACC office bearers for making it convenient and presided over this seminar. I appreciate your consideration, guidance, help, time. We will be grateful to welcome your service support in the coming year also. I want to extend my grateful thanks to all the eminent speakers for their participation and sharing the knowledge with us in this 2 days seminar. I convey our thanks to the guests, fellow fraternity engineers, and beloved audience who made it convenient with us for this important seminar and making as a grand success. Thank you so much for Warangal and Rajahmundry Center for making highest registrations. It's time for applause for Rajahmundry and thank you. I'm very much thankful to the sponsors and exhibitors for their continuous support in organizing this seminar. I would like to thank to all our ACCE management committee members, co-op members, advisors, and also who worked hard directly and indirectly and for their valuable suggestions and cooperations in making this seminar becomes memorable success. I also extend my thanks to the hotel management, event organizers, print and electronic media, and photo videographers for your amazing services. And also thank you Anvesh, Mani, and all other cooperative members, members. Last but not least, we are extremely thankful to the Master of Ceremony MC, Architect Chetana ma'am. You did an amazing job. Thank you so much, ma'am. Once again, I thank you all for the attention and present here. I thank once again everyone whose contribution has made this seminar a successful one. I request all of you please stand up for national anthem. Thank you. I requested visual jockey, please play the national anthem. Thank you.
Jana Gana Mana Adhinayak Jaya He Bharat Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Ujjala Jaladhi Taranga Tava Shubha Name